What is up, guys? Fahir here from AwesomeDudes.com. Whoa, haven't said that in a while. Anyways, before we start creating anything, I am going to preview the game that we're gonna create. So I'm gonna hit the play button, and you will see now that we have our warriors that they will fight each other. Don't mind the buttocks that you can see from the character. So you see the enemy is chasing us and trying to attack us. Actually, he hit me. Pay attention to the health bars at the top left and top right corner. And by the way, I can hold the shield like this. When I hold the shield, he is not able to attack. And now when I lower the shield, he will be able to attack. You can hear the public behind in the background. Let me just up the volume a little bit. So you can hear them cheering. They like when blood is spit. Anyways, I'm going to attack the enemy. And as you can see, I am dealing more damage because, hey, I don't want to lose in the game that I'm creating. I don't want to embarrass myself. And when his health gets to 0, basically I have to hit him 2 more times. So 1 more time, bam. You see now, he is dead. And voila, I have won. And the enemy's health is 0, as you can see at the top right corner. Basically, this is the game that we're going to create. We have melee battle system, something we did not do before. We have enemy AI that enemy can detect where the player is and it will chase the player. Also, when the player goes away a little from the enemy starts chasing the player again. So let's start creating this. I'm in a new project. Let me close this one because I don't want it to be open. Let me close it like this. So right click here and finally it's closed. Anyways, this is our project. Here we have our sample scene. This is a new 3D project, by the way. So you're simply gonna go and create a new 3D project. Name it however you wanna name it. I named this one Warrior Fight Game. This sample scene, I am going to change to gameplay just so I like to name things correctly. And we are going to import the assets. By the way, the assets and the complete project are available for you to download. Link is in the description below. So select all of these assets, model, sounds, textures, and UI, and simply drag and drop them right here inside of Unity. Of course, it will take a moment or two for Unity to load all of this. You know the procedure, it takes some time to import the 3D assets. And yeah, while we wait, I can sing to you or we can stop the video. Let's actually try the singing. No. I'm just kidding. I'm gonna stop the video and come back when everything is finished. Finally, Unity took mercy upon us and it has imported all the assets and we can start building our game. The first thing that I want to do is create the terrain or the ground where we are going to stand. And for that, I'm simply going to right click here in the hierarchy panel and go under 3D object and create a simple cube. Voila, this is our terrain. Now, of course, not this cube. We are not going to stand on a cube. Actually, we are, but I'm going to resize it. And I'm going to call it ground. For the scale X, I'm going to say 100. For scale Y, 0.1, because I want to make it, thin like this. I don't want to make it, large. I don't know what's opposite of thin. Don't judge me. Anyways, I'm going to say here Z100 as well. Voila, this is what we have. This is going to be our terrain. Now, of course, it is not pretty at all. I don't want this whiteness tearing my eyes apart. So if you pay attention here inside of the folders or the assets that we have imported, we have textures. Inside of textures, we only have this grass texture. If I open it, this is the grass texture. Basically, somebody took a shot in his backyard. Anyways, what we're gonna do here is we are inside of the textures. I'm going to right click and create a new material. So here it is, right click and create. So again, it's right click and go under create and material. This is what we want. And I'm going to call this one ground material. And we are going to apply it on the ground. So now I can drag and drop this on the ground, and this is how you make game objects look cool, basically. Because pay attention to our ground, it's white. If I put this material on it, it's still white though. But what I can do, for example, is I can change the color to now red or dark or silver or whatever. But I can also drag and drop this grass inside of this albedo or albedo. Do I have my highlight tool? Here it is. So if I take here, as you can see, I have the grass, and if I drag and drop it right here, it will display that grass, voila, on our ground. Voila, this is how you make things look good in Unity and in 3D. But there is more to these materials and shaders. Now, this is the first time I mentioned shaders. So what are shaders? Basically, a shader determines how that material or the texture that is applied to that material looks like. So if I take here, pay attention, I have the standard shader. This is on the drop-down list right here. So here it is. I'm highlighting that with my highlight tool. So when you click on that, it's a drop-down list, and you can play with all the different shaders you have built in. Of course, there are others that you can import from the asset store, but these are built in. What I like to use is this one, unlit texture, and you see it's already a little bit different. It's a little bit darker, so the grass looks a little bit darker in comparison to what it looked like a moment ago. And I encourage you to experiment with these shaders so that you can see their effects. Not every shader will make your material look good. Maybe some will look bad, others will look better, but you can find that out if you experiment. So for example, if I go here, I don't know, nature, and say speed tree, maybe this will not make it look good. Well, basically it's a little lighter. And some shaders also have other fields here where you can add a texture, you can have a normal texture. Now, I'm not going to go into that, that's a different topic, and I don't know too much about it, but basically when you combine these textures like a normal map, another texture, some other textures that come along with it, you make your material look, or the game object that has that material look good. Anyways, what you need to do is simply experiment with these. Just experiment, try them out, and see different effects that you will get. And that's how you learn the best. Now moving forward, we have our ground, and again, the scale X is 100 and Z is 100, Y is 0.1. Why? Well, because, pay attention, if I set the Y, for example, at 100, I don't want this. What the hell is this? You see, we don't want this. We only want our ground, so we want to make it look like a ground. That's why I put the scale so that it's not too large on the Y axis. So moving forward, if I go back in assets and models, we have the arena here inside of the models folder. So in the models folder, we have the arena. If I click here, this is our arena. If I drag and drop it, here it is. This is the arena. Dun, 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 dun. Now, of course, it's too small, so we need to resize it. Make sure it is positioned at 0, 0, 0 for X, Y, and Z, and I am going to call it Battle Arena. So this is the name of the game object. And the scale for X, Y, and Z is going to be 25. So 25, 25, 25. And voila, this is our arena. It already has materials applied on it. If you click on the drop-down list, you will see all of these different game objects that are put together to make this arena. If I, deactivate some of them, so if I, let's try deactivate these, you see the effect. If I deactivate them, well, they are gone. So that is another thing that you can experiment, but basically these are just 3D models put together. So put together to create this battle arena. You can see here we have some people spectating or whatever. Yeah, this weirdo, look at that weirdo. Yeah, these two, they're probably up to something. Yeah, anyways, I don't know what I'm saying, but this is our battle arena. Now, moving forward, we are going to import our character, and here he is, our warrior. Now, one thing to note is this is a headless warrior, so if I drag and drop him here, and if I go to him, voila, this is a headless warrior, like a headless swordsman. But of course, we are going to make him with head. So I don't know how you say head. What's opposite of headless? Head-oness? I don't know. Anyways, this is our game object. So what I'm going to do is, first of all, I'm going to take and rename it. So from body_0, I'm going to rename it to warrior. Next, we need to apply this head on him. So if you pay attention to the head, now it's too big. We're not gonna do this to him anyway. Pay attention to the head. Look at that. We're not gonna do this to him. We are going to resize the head a little. So I'm going to resize it. Let's say here, head is going 1, 1, 1. Actually, no. So the head is gonna be 1.5, 1.5, and 1.5. Yeah, exactly. So 1.5 for the head. This is totally fine. And we need to select the warrior. Click on this drop-down list to go through all of the elements that make him, or to his body parts. So click on the warrior, then this BIP001, click on that drop down list. Then again, you have BIP001 pelvis, click on that one. And let me just resize this here. Then we are going to go under spine, then spine 1, then spine 2. Man, this model is killing me. Then we have the neck, and right here we have the head. So what you can also do is in the search bar, if I take the highlight tool, here you have the search bar in the hierarchy panel. You can also select the search bar and you can type here, for example, head, and it will find it for you. It's this one right here, BIP001 head. So this is the part of the body that we need. So now we're gonna drag and drop the head right here. Normally we don't have to do this because other models come with the head, but this model is like this. So what I'm gonna do is I am going to resize it, or actually reposition it. So I'm going to say 0.016. This is going to be for the X. For the Y, it's gonna be 0.012. And for the Z, it's gonna be negative 0. Let's say here, I don't know, it's gonna leave it just at 0. Just a 0. Leave the Z at 0. And I think his head is also still too big. So yeah, this is okay. And let's take here and resize the head a little bit. So the scale is going to be 0.47 for X, Y, and Z. I think now it's okay. So when you select the head, set the scale to 0.47. That is 0.47 for X, Y, and Z. The position X is going to be negative 0.0274, and Y is going to be 0.012. And yeah, this is where our head is going to be. Exactly. And it looks good. It looks good. Actually, it looks like it's already built on him. Anyways, as I said, we are not going to do this that often because most models come with the head, but this one is like this. And what we can do, or yeah. Anyways, select the warrior now. And what I'm going to do is I'm going to click on this add component here. And we are going to filter for character controller. This is a built-in controller that comes with Unity. So if I select it here, again, it's under add component and filter here character controller. As I said, this is a built-in controller, and I don't know if you can see the green things around him. So yeah, I've turned off the ground at the battle arena so we can see this capsule thing around him. Basically, this character controller comes with a collider and also comes with a rigid body in it, so we don't have to apply these things. This green thing that you can see is a collider that's around our player. So what we can do is we can reposition it. So I'm going to put it on my 0.96, and for the X I'm going to leave it. Z, I'm going to leave it. A radius, however, is going to be 0.25. And voila, you see the radius, it will resize that collider. Now it can be a little lower. I don't know, for example, 0.21. Yeah. And you can see now it is around our player, well, around the middle of him. And this is, as I said, the character controller that we are going to use in order to make him move. And by the way, let me just put him like this. So if I put him like this and if I hit the play button, actually, where's my camera? He is standing still. Now, even though we have a rigid body, we have a velocity in our character controller, we still need to apply gravity on him. So we need to apply gravity, and in order to apply gravity, basically we do that via script. So it's time to get our hands dirty. Let's go back in the assets and right click here and create a new folder, which I'm going to call scripts. Inside of the scripts folder, we are going to right click and create our player move script. And by the way, before we continue, what I'm gonna do is go back here in assets and right click and create a folder. This one is going to be our prefabs. And click here in the prefabs and drag and drop the warrior. So bam, this is our warrior prefab now. So we don't have to worry about deleting this game object from the scene and doing all of this from beginning. So if we go back in the scripts, we have the player move script, drag and drop it on the warrior, and now hit apply here so that that change applies to the prefab. Now, one thing I want to get out right now. I like when I go and spontaneously have things that I need to explain. Why we need to hit apply to make that change apply to the prefab. And if you're watching my tutorials, you probably heard me saying that like 1,000 times. Well, this prefab right here is basically now the original game object of this warrior that we have in the hierarchy. So let me just take it. So this warrior here in the prefabs folder is the original one. This one right here is a copy of it. Any change we apply to this copy, for example, if I go here and if I attach an audio source component, pay attention here, I have attached an audio source component on the copy in the hierarchy. The original one, the warrior here in the prefabs folder, he does not have that audio source applied on him because we attached that one on the copy. If you want to have the original have this audio source because you attached it, you will need to click on this apply, and this apply applies that to the original prefab, which is right here. Here it is, the original prefab in the prefabs folder. So if I select the warrior prefab in the prefabs folder, it has the audio source component attached on him now. But pay attention now, if I go here to warrior and remove, and this is the warrior in the hierarchy, the copy. If I now remove the audio source component, the original still has the source component, the audio, because we did not hit apply. But pay attention to the difference now. If, however, I select the warrior inside of the prefabs folder, the original one, and if I go here, for example, and filter for a rigid body component, and if I apply that rigid body component on the original, what do you think for the copy? It will have the rigid body applied. Because we applied it on the original, and the copy will simply follow because it's a copy of the original. But if we apply to the copy, then we need to click apply to make that change apply to the prefab, the original one as well. So if I remove now from the warrior prefab the original one, we also don't have it on the copy prefab. So I hope this clears things out. If not, ask what is not clear in the comments below. So let me go here. Actually, this is from the previous one, the one that I have previewed it. So moving forward, this is the new one that we are going to code from scratch. Let me just click here and hold enter to give a little bit space. So what do we need for our player move? First of all, we need our private character controller, and I'm going to call it char controller like this, not character, but char like this, short for character. We will also need an animator, but we will do that later on. We also need here public float movement speed, which is by default 3, and pay attention, I set it to be public, which means it is editable in the inspector panel. And what do I mean by this? When I say it is editable in the inspector panel, that means a public variable is visible here in the inspector. Pay attention here now. You see, we have it right here. Let me click on the highlight tool, and here it is. So we have it. It's right here, which means we can manipulate this value. If I set here value 5, now we have the value 5 and not 3. So if I put it back at 3, it is 3. Basically, the value that we put here in the inspector panel will override the value that is here. So we have the movement speed. We also have a public float gravity. This is what I was talking about, which is 9.8. This is the gravity in real life as well. We also have a public float rotation. So rotation speed, which is going to be equal to 0.15 F. We also have a public float rotate degrees per second, which is going to be equal to 180 degrees per second. So these are the variables that we need to get started. And the first thing that I'm going to do is inside of the awake function, of course we have the start, but I'm going to change it to awake. If you are also following my tutorials, you know that I like to initialize things in the awake function because the order of execution goes like this. When we run our game, this is the first function that is called. The second function that is called is on enable, this one right here. And this is the second function. And the third function is start. So start is the third function, but by default, when we create a project, we have start and update. Of course, we can use start for initialization. And in some cases, it is better to use start over awake. For example, and I know somebody will ask, when is that case? Well, if you are initializing something in the awake function and you need to get a reference for that, then initialize it in the awake, but get a reference in the start function. This goes, for example, if you select a player in the main menu, you initialize the player in the gameplay scene in awake, but you need to follow it with the camera. Then in the camera, use the code that will find the player in the start function. We will have examples for this in some other tutorials, so don't worry about that. Anyways, I'm going to say here chart controller is equal to get component character controller. And voila, we are basically done with our character controller. What is the next thing to do is go here and create void move. And this is a function that we're going to use to move, which we're going to call in the update. And here we're going to have move. So what are we going to do here? First of all, we are going to test if input get axis, and here we are going to say vertical like this, is greater than 0, which means if we have either pressed the up arrow key or the W key on our keyboard, because if I take here quickly the highlight tool, and this is the coordinate system. So here we have Y, here we have X, and here we have Z, because this is a 3D game. And basically up on the Y is plus, down is minus. On the X-axis to the right is plus, which means the positive side, and on the left is negative. And for the Z, forward is the positive and backwards is the negative. And basically here, we are testing if we are touching the vertical axis, which is the Y-axis. That's the vertical axis. But we're going to use this to move our character forward. And right here below, we are going to say else if input.getAxis, and here we're going to say vertical. If that is less than 0, then that means we are going downwards. And to paint a clear picture, I'm going to use here print, and I'm going to say the value is, and I'm going to say here plus, and we're going to use this input and vertical so that you can see the output actually of this, what this value will be. So if I go back here in Unity and let me go into the console and clear it. So if I hit the play button, pay attention now, as long as I'm not pressing anything, it will be 0. But when I start pressing, so I started pressing, actually I did not. So now I'm gonna start pressing, and I'm pressing the up arrow key. And this is what we have. Let me just go here because it happens so fast. It's in the update function. It updates every frame in a second. So pay attention here. This is where I started to press, and notice the values 0.04, then 0.096, then 0.14, then 21, then 31, up to 1. So it goes from 0 up to 1 in these increments that we just saw. So 0.1, then 0.15, then 0.2, so on and so forth. You get my point. And for the negative, if you press down, that is the S key or the down arrow key, you will get from 0 to -1. And you saw the increments. It goes slowly from 0 up to 1. If you want to go directly from 0 to 1, then you will use getAxis raw. GetAxis raw has the same exact effect. It will detect when you click, or actually when you press the up arrow key or the W key, or when you press the S key or the down arrow key. But when you press the up key and W, it will return from 0 to 1, but it will go directly from 0 to 1. It will not go in these increments that we just saw. You can print this and see for yourself. Now, one other thing that I don't like about this code is this right here. Not the word vertical, but instead me hard coding values. This is something I don't like to do. So if we go here in Unity and go back in the project tab, inside of the scripts folder, I'm gonna right click and create a new script that I'm going to call tags. So tags, and here I'm going to double click it. We're not gonna attach it on any game object. And I am going to remove this public class declaration. So what are we going to do? Why did this go right here? So what are we going to do within our class? Well, first of all, I'm going to create here a public class called axes. And here we're going to have a public constant string. and I'm going to call this one vertical. So vertical axis, which is going to be equal to vertical like this. And we're also going to have a public constant string, and this one is going to be horizontal. So horizontal axis, which is going to be equal to horizontal, as you can assume, because we're going to have vertical and horizontal. Now, don't mind these red errors that I have. This is because my computer was open for such many time or for so long, so I have to close Visual Studio and reopen it again to make this actually work. So now when it's open, bam, here it is. So now everything is working like a charm. As I said, I don't like hard coding values like here, because if we use this on 2 places or even more, it can happen that I misspell something, because if I type vertical with lowercase v, it's not gonna work, even though the word is the same. So capitalization needs to be the same. And when we use it like this, when we declare it in a single place, we can simply do this. Instead of typing it like this, we simply say here, axis dot vertical axis, and bam, this is it. And here we do the same thing, axis dot vertical axis, and bam, it's the same exact thing, except here we have it in one place. And notice here this constant will not change, same like in math. Now you don't have to be a math genius to know that, but basically if I do something like this, if I say axis dot vertical axis is equal to me changing it, it is not going to work because it's a constant. Anyways, moving forward, now we're detecting if we touch or if we press the up arrow key or the W key, and here if we press the down arrow key and the S key. So if we press the up arrow key, we want to move forward, and in order to do that, we're going to say here vector3 move direction is going to be equal to transform forward. What the hell is this transform forward? Well, if I hover over, it says the blue axis of the transform in the world space. In order to paint a clear picture, if I take my warrior here inside of the scene and I zoom in on him, do you see this blue axis, this blue arrow that I'm taking and dragging him? This is that axis, indicating the forward. So no matter where he is, because we can rotate him, if I do something like this and I rotate him, you see now forward is this way, not the way where it was. So basically it was this way forward, but when we rotate him, you saw what I mean. And this right here, the transform forward, is telling us the move direction is to move forward. So now we're simply going to say move direction dot y minus equals gravity multiplied with time dot delta time. In order to apply gravity, this is what I was talking about in the beginning. So when we attached actually the character controller, I said that we need to manually apply gravity to our character, and this is how we do it. This is how we apply gravity, by subtracting from y gravity multiplied with time dot delta time. Why time dot delta time? Well, because we are calling the move function in the update, and if you want to smooth out things, because update is called every frame, or actually once per frame. If we have 60 frames in a second, that's 60 times in a single second this function will be called, which means this one will be called as well because we are calling it in the update. Now, if we subtract from y gravity only, which is 9.8, that's a it's gonna happen very fast. It's a huge number, and we are subtracting that every frame 60 times in a second. That's why we need to multiply it with time dot delta time, and time dot delta time is the difference between each frame. So how many time it took to go from last frame to the next one, that is the delta time. And it's a very low value, and that is the reason why we use it to smooth things out. So moving forward, we have here applying our gravity. The next thing to do is simply call our character controller and move in order to move our game object. So we pass here the move direction. This is where we want to move, multiplied with the movement speed, multiplied with the time dot delta time to smooth things out. Again, smoothing things out with time dot delta time, same reason as what I explained right here. And this is, we're moving in this direction, but we are multiplying that with the speed movement in order to speed up the movement. Now, what I'm going to do is here for our negative, or actually when it's lower than 0, that means we need to go backwards. So I'm simply going to copy these lines of code and paste them right here. And since we don't have transform backwards, we have forward, but we don't have backward, I'm simply going to use the negative. So I'm going to say minus transform forward, which is simply the negative of forward. What is negative of forward? It's backwards. Think of it as opposites. So this is going to have the same effect except backwards. And here we are using move direction, which is now backwards, multiplying that with the movement speed, multiply that with the time.delta time, and we can test it out. So if I go here, and one thing, another tip from me, take notes when I say these tips. If you want, for example, if this is where you want your camera to look, for example, in your scene or when you run the game, instead of using the camera and positioning it, I don't know, at 10, 20, 30 position, for example, and this is where that position is, or dragging it and dropping it, simply what you're gonna do is position here the view how you want it or where you want the camera to look in the scene. Select the main camera in the hierarchy, and on Mac, hold Shift and Command. On Windows, it's Control Command and press F. So when you press F, so now pay attention where the camera is. Exactly same place where we are looking in our scene. Now that we have that done, I can hit the play button and I can test this out. So we have the player and voila, I'm pressing the W key. Now I'm pressing the arrow key, up arrow key, and W, he's moving forward. I'm pressing the back arrow key and now I'm pressing the S key. He is moving backwards. So voila, this works. The next thing on our agenda is to rotate our game object or the player. So let me just go here, and this one is for the move, and here void rotate, and this one is for the rotate, which we are going to call right here in the move. So we're going to say a rotate like this because move is called in the update, and we can safely call rotate below it, or you can simply take the rotate outside and you can call it here. It does not matter, it's the exact same effect. So in the rotate, we are going to say here vector3, which is the rotation underscore direction. By default, I'm going to say it's equal to vector30. This is the default one because vector30 is a shorthand for writing vector3 0 0 0 for x, y, and z. Because we're going to detect input again. We're going to say if input.getAxis, and we're going to say here axis, horizontal axis, if that value is greater, or actually if it's lower than 0. And here we're going to say else if input.getAxis, and again here axis.horizontal. Now here we're going to test if it's greater than 0. And we're going to do the following. So if it's lower than 0, that means we are pressing the A key. Again, this is the coordinate system. This is the horizontal axis, meaning the x-axis. Going to the right side is the positive. Going to the left side is the negative. So if we press the A key or the left arrow key, we're going to the left side, which is negative, which means this right here will be lower than 0. If that is the case, we're simply going to say here rotation direction is going to be equal to transform point, or actually transform direction, and here we're going to say vector3.left. Now I'm simply going to copy this and paste it here, and you can assume that here it's going to be vector3.right. And by the way, this one is going to be separate, so we're not going to do if else or else if. And why did it give me this axis here? Anyway, here I'm going to say if input get axis. We are not going to use if else. Simply we're going to do if and if, because we can press these buttons simultaneously. So if we press the A key or the D key, they will cancel each other out. Anyways, moving forward, what is this transform direction? Well, if I hover over it, it's going to say transforms the direction from local space to world space. What is that? What is local space? What is world space? Let's go back in Unity to explain the local space. If I take the warrior, and of course, I'm going to go in the scene first and zoom in on the warrior. This is my warrior game object. If I right click on him and create an empty game object that I am going to tag here with this orange or yellow tag, you see this game object right now inside of our, so he's basically inside of our game object, our hero. If I move him here, and now he is in front of him. If I take the X, set it at 0, take the Y, set it at 0, take the Z, set it at 0, now he is back at the center, and his center is around his warrior player. That is his local axis. That is the local axis, his own origin. So his own origin of that game object. And with origin, I mean where that game object goes when we set 0, 0, 0 for X, Y, and Z, or when we reset the position on the transform. Where does he go? That is his origin or his local axis. Local position, that is. If I go here, you see transform direction from local space to world space. But what is the world space? Well, world space is all of this here. You see? Everything that we see here, so where our cube is, or actually our ground, where our battle arena is, where our player is, that is Unity's world space. And this is where we are moving. When we move this character, we are moving him in the Unity's world space. That's where everything happens. So we are transforming the direction here, which is vector 3 left. And if you go here, a shorthand for writing -1 for X, 0, 0 for Y and Z. And the right is +1 for X, 0 for Y and Z. Basically, we are transforming this into the world space, and this will transform it into the left side of our game object inside of world space. And it will do the same thing here for the right direction. So now that we have the input for the left and the right direction, we have here the rotation direction. Right here, we are going to say if input dot, or actually now we need to rotate our game object. So we are going to say if rotation direction is not equal to vector3.0. So if it's not equal to 0, that means that we have here input. And that's the reason why I'm setting it here to be equal to 0, because we are resetting it every time. If we don't reset it here, then the value that we get here will stay the same, and here it will stay the same every single time. So we need to basically reset it here to 0, so vector3 0. But if it's not equal to vector3 0, that means we got input here. So what we're going to do is simply we're going to say transform a rotation is equal to quaternion dot rotate towards, and this will rotate from rotation, that is from the transform rotation, to rotation. It's going to be quaternion look rotation, and it's going to be a rotation direction in the given speed, and or actually degrees, and the degrees is going to be a rotate degrees per second multiplied with time dot delta time. What the hell is going on here, teacher? What are you doing? You are driving me crazy. And okay, let me just calm down. I'm gonna not drive you crazy anymore. Anyways, you see here transform rotation is gonna be equal to this. Rotate towards, you see here rotates a rotation from towards to. This is from, so it will rotate from this rotation to this rotation in basically these or this degrees. But this is clear. It will rotate from the current rotation it has towards this rotation right here. Now look, rotation basically creates a rotation with a specified forward and upward direction. Basically, this will do the following. Since we are rotating around the y-axis, this is the y-axis, and it will create a rotation around the y-axis, and the forward will be placed on the y-axis. Basically, if the y rotates over here, so now y is here, then the forward will be here. You get my point. Now the reason for that is because, let me take our warrior. You see here, pay attention to the blue axis, so this one right here. If I rotate him, you see how the blue axis rotates along with him? Basically, this is what we are doing with look rotation. It will look at the rotation from the y-axis. It will basically rotate it from the y-axis, which is what we want. We want to rotate on the y-axis. And this is the degrees by which we are rotating the game object. So rotation degrees per second that we added here, 180. Multiply that with the delta time to smooth it out. If we don't smooth it out, every frame we will rotate exactly 180 degrees, and that will be fast, really fast. So if you want to test it out, you can do it by simply doing this right here. Basically, let me just do it just to test out and show you the effects of the smooth time. So if I go here and if I run the game, so pay attention now if I rotate. You see, this is what happens when you rotate like this. You see, this is what happens because we are rotating so fast. This is 180 degrees per second. If we don't multiply it with the delta time to smooth it out, then you saw the effect. Exact same thing will happen for this here if you don't multiply with delta time. Exact same thing will happen here if you don't multiply that with time dot delta time. But if I hit the play button now that we are multiplying that with delta time, pay attention now, I'm going to press right actually. So right, you see how he's rotating now smoothly. And left, and he's rotating also smoothly. So now we can move and rotate. So now our game object can move and rotate at the same time. You see? Moving and rotating, and voila. So I'm pressing left and I'm pressing right, and he is rotating towards the direction where I am pressing. Voila, this is how we move a character and how we rotate a character. So the next thing to do is to make the camera follow the player. Of course, we also need to animate him, but using the camera to follow him will be much easier because there is less code involved. So I'm going to right click here and go on create and C# script. And I'm going to call this one camera follow. And I'm going to show you two ways. How can we make the camera follow the player? Because this is programming. There is always more than one way to solve a problem. So select the main camera and drag and drop the camera follow script on the main camera. So drag and drop the camera follow script on the main camera. I'm simply going to double click it and open it here in Visual Studio. And let me just tag the class. And we don't need here that many lines of code. Basically, we need the following. So we need a private transform, which I'm going to call target. And this is going to be our player. We will get to it in a moment. We also need a private vector3 offset. Now, it's a private variable because I don't want it to be accessible in other classes, but I also want it to be visible here in the inspector panel because I want to edit it. So in order to do that, we simply open square bracket and type serialize field, and voila. So open square bracket, close square bracket, in between type serialize field, because now if I go back in Unity, that private variable will be visible here in the inspector panel. Bam, and here it is, right here. And you can simply remove, what did I do? So let's go back here. And you can simply, let me just hide this. So you can simply remove this line of code to test it out, to see for yourself. If you remove it, it will not be visible in the inspector panel anymore. So moving forward, from the awake function, not the start, I'm going to get the target. So I'm going to say target is going to be equal to game object, find the game object with the tag, player tag, dot transform, because we're getting the transform property. Again, two issues we have here. First of all, this right here is a no-no. I don't like it. So we need to go back here in our tags, and we're going to create a public class called tags. And we're simply going to have a public constant string player underscore tag, which is going to be equal to player. This is the first thing and the first issue, same as with our axis, and I explained that why. So if I go back here, remove this, and we're going to say tags.player tag. It's the same exact effect. Now, in order for this to work, you need to make sure that your player, the warrior, when you select him, and right here you have the tag property in the inspector panel, you see where I'm pointing with the mouse, you can click on it. So let me just hide here, and you can click on it, and you need to select the player tag. By default, I think it's from Unity 5 version and upwards, you have here a tag player. If by any chance you don't have it, you're gonna click here on add tag. So click on add tag, and now here where you see tag and list is empty, click on this plus button. So this small plus button right here that I just pointed to. So when you click on it, it will open this short window. You will type here your tag, click save, and then that tag will be available to you. So now that you created a tag, you're simply going to select the game object, go here and tag it. So click on the tag you want to tag it, and pay attention, please. Please, this is a tip, so note it down. If the name here is player with P, capital case P, it needs to be the same exact name right here. If you type here lowercase p, it will not work even though it's the exact same word. So capitalization also needs to be in order. This is really important. So now we have a reference to our player. We have the offset here inside of our, or actually below the update, we're going to create void follow player. And we are going to call this function inside of the late update function. So no update, but late update function. And what the hell is a late update? Well, let me first explain. We have the update function and we have the fixed update function. Update function is called every frame in a second. Basically, if we have 60 frames in a second, then it will be called 60 times. Update function is good for moving a game object using the transform property or the character controller, as we are already doing. And also for getting input, which we are also doing here. So we're getting input. We do that in the update function. Fixed update function is not called every frame, but it's called in a fixed number frame intervals. What does that mean? It's basically called every third or fourth frame. And this right here is dependent, or that is dependent on, if we go under edit and go here under project settings and then time, if you take a look here, let me just clear it with the pencil. You see here this fixed time step, it's set to 0.02. It's dependent on that time. Basically, fixed update function will be called every 0.02 of a second. And it's good for physics calculations. So if you want to move your game object using the rigid body, you will do it in the fixed update. But what the heck now is the late update? Well, late update is same as update. It will be called every frame, but it will be called after the update finishes. So if we have something like this, for example, I don't know, int a, b, and c, and we want to say here c is equal to a plus b, this calculation will be already done, and we can use the value of c in the late update, and it will be this value here, calculating a plus b, and it will give us the value c, and we will be able to use that in the late update. Late update is really good for using code or typing out code that will be for example, like this, in order to follow the player, because we are moving the player, as you can see here, in the update. So in the update, we will calculate his position and he will arrive at that position. So now in the late update, we already know where the player's position is and we can follow him smoothly. Now, in order to follow the player smoothly, what we simply need to do is we need to say transform that position, our own position of the camera, is equal to target player. So the target, which is the player transform, as you can see right here, and we're going to use the player transform to transform direction, or actually transform the point, and we're going to transform the point offset. So offset, and basically, let me just go here. I'm going to name it offset position, not to be confused with that wrapper offset. It's offset position. What is transform point? You see here, transforms position from local space to world space. Again, basically, same thing as what we did with transform direction. It will transform this point from the local point of the target. But pay attention here, pay attention please. We're using here target, which is the player's transform, as you can see here. So it's the player's transform. It will transform that point from the position of the player. So from the position of the player, it will transform that point, and it will transform it from his local position to the world position. And if we test it out right now, the beauty here is that our main camera now has these visible in inspector variables for the offset X, Y, and Z. And what we can do when I hit the play button, you will see now where the camera is. It's basically here. But what I can do is I can move here the Y axis, I can move the Z axis, you see now, and I can set it where exactly I want it to be in order to follow our player. And I can set here 0 for our Y axis. And basically, what I'm going to do is I'm going to set this at 30. So 30 for the camera for the rotation and 0 for the rotation Y. But if I hit the play button now, you will see that it will transform now the position. And what I can do is this. So voila. You see now, this is how I can make the camera follow the player. Now, of course, here for these values, I'm going to say 2.25 for the Y. And for the Z, negative 1.9. Or actually, it can be a little closer. Something like this, maybe. Negative 1. This depends on you, but now, pay attention, now that we saved, or actually we did not save these values because we are in the play mode. What I'm going to do is click on this gear icon. You see the gear icon on the camera? So click on the gear icon and it will open this list here, and you're gonna click on copy component. So when you copy the component now, and if I go back here, you will see that the values are back to 0 because we edited those values inside of the gameplay mode, which means they will not be saved. In order to save it, we did that, gear icon copy values. So now that we have them copied, we're gonna see here paste component values, bam, and voila. So now we have the values here, -1 for Z, 2.25 for Y. And if we test this out right now, if I hit the play button, you will think that the camera is gonna follow the player, which actually is the case. But if I rotate, you see what is happening. This is not the effect that we want to achieve. Now, we got carried away, we programmed the position of our camera, but we did not take the rotation into consideration. And I like to do things like this. I like to show what is the problem, and I like to show what is the solution to the problem, because we are rotating our character. We saw that, so we are rotating the character right here, as you can see. And let me just move this backwards. So we are rotating the character, but we also need to rotate the camera. So here, I need to say transform.rotation is going to be equal to target.rotation, simple like that. Because our transform rotation is the rotation of the camera. So transform referring to this class or that game object that's holding this class. So transform and rotation is going to be equal to the target rotation, and target.rotation is the player's rotation. So the rotation of the player game object. And now if we go back in Unity and if I hit the play button, you will see that when we rotate our player, we will also rotate, you see, rotating the player, rotating the camera. And we can move the Z-axis, let's say -2. Yeah, -2 for the Z-axis. Remember that, or actually just close the game, select the main camera and set -2 for the Z-axis. So -2. If I hit the play button again, now we move forward, we rotate, the camera rotates along with the player. So this is how we do it. We also set the position and the rotation if we also want to follow the rotation of the game object. Now, is there another way to make the camera follow the player? A more simple way? Of course it is, because this is programming. This is creating an application, and there are multiple ways always to solve a certain problem. This one is much simpler, and for that I'm simply going to duplicate the main camera, and I'm going to set this main camera, turn off the first one, the main one, and this one I'm going to rename to camera in player. So I'm going to rename it to camera in player, and I'm also going to remove the camera follow script because we don't need it. So remove component, so remove the component camera follow script. And what I'm going to do is simply drag and drop this camera on the warrior game object, and it will make it a child of that game object. So basically now wherever we move, if I hit the play button, because the parent is moving, you see now the child is moving as well. And the best thing here is you can position the child wherever you want. So we can say the X position for the camera is going to be 0, the Y position 2.7, and the Z position can be negative, let's say 1.8. So negative 1.8 will be the Z position. And rotation, we can leave 30 for X only. And basically this is how it looks like. So you can rotate it like this, however you want it. But I'm going to set it at 30. Again, you can experiment with this. This is totally up to you. The more you try, the more you will learn. I encourage you to try all the time, so experiment with it. Now that we have this camera as a child of our player game object, I'm simply going to hit play, and wherever the player goes and however he rotates, the camera simply follows without a script, because what the parent game object does, the child will follow. And the warrior here is the parent, the topmost parent. All game objects, when you click on the drop-down list on the warrior, all these game objects are children of the warrior game object. And if we click here on the drop-down list for this BIP001, these footsteps are children or a child game object of this BIP001. So on and so forth, you get my point, but they all are the child of the topmost parent, which is the warrior. Now we need to hit apply because we attach this camera in the player, but again, this is another solution depending on your situation. So sometimes you also want to have the camera inside as a child, and it will follow the player wherever he goes. And it's more simpler. Basically, we did two ways. One was using a script, and another one is simply making the camera game object as a child, and it will follow the parent wherever the parent goes. The next thing to do is to create the animations, and we're gonna go here in the models, and here we have the animation. So right here, I am going to right click here where all these animations are. So right click, and I'm going to create an animator controller. So click here, and I'm going to call it warrior controller, like this. Because if I select the game object, which is our warrior, you will see that he already has an animator component attached on him. So here it is. And we simply need to drag and drop this animator controller, the one that we have just created. We need to drag and drop him right here in this empty field. And then we can add animations to it, and we can control it via code. So if I take here the warrior controller, drag and drop it here, bam. So this is the controller now. We have it attached on the animator of the warrior. The next thing to do is go inside of the animator tab itself, and this is where we are going to create the animations. Now, if you don't have this tab, what you're gonna do is the following. Go under window, and then you have here animation, and here it is, animator tab. So this one right here. So you have the animation, you have the animator. We want the animator, so animator, this one right here. Now, in order to create these animations, basically we don't need to. They are already created here, but we only need to connect them with the controller. So while you're in the animator tab right here, right click and create state and empty. So right click, create state, empty. Voila. This is going to be the idle animation. And in order to rename this one, you see the name is new state. If you want to rename it, simply click on it. And now here in the inspector panel, you will see here at the top, let me just go here and clear the console, or actually clear the pencil. So here it is, you see the state, this is where you will rename it. And here where it says motion is where we are going to drag and drop the motions or our animations. So here new state is going to be idle. And simply what we need to do here is, you see, we have the idle 0 and we have the idle attack. So if I select this one, this is that animation. If I go here and preview it, so click the animation, basically clicking on the drop down list for this idle. And here we have idle _0. Now, if I preview it, so if I zoom in on this preview here at my bottom right corner, and this is the idle animation. I'm not gonna preview the whole animation because it's long. So go back here in animator, click on idle, and here where I said that you need to drag and drop that animation or motion, right next to it, you have a little circle. Let me show that circle. It's right here, you see? When you click on that circle, you will be able to select these animations. So here we have idle 0, and select the idle 0, and voila, idle 0 is not here. Why? Well, if we go here in the console, it says animation clip idle 0 cannot be used in the state idle. Legacy animation clips are not allowed in animator controller. What does that mean? Basically, it means the way how we import them. So we need to select all of these animations. So select from attack 0 to idle attack 0 and walk. Select all of these animations. And right here now, inside of the inspector panel on my right side, you see here we have model tab, we have the rig, animation, material model, so on and so forth. Click on the rig tab. In the rig tab, we're going to change the animation type from legacy to generic. So again, click here, generic, click on the drop down list where it says legacy, which is right here, this right here, you see? When you click on that drop down list, you will change it from legacy to generic, and you will hit apply, and bam. Unity will, you see, like re-import these assets with this animation type, but it will re-import these assets right here, only these animations. And of course, it takes a little bit of time where I can use it to sing na 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 na. No, I'm just kidding. Anyways. I have fun recording these videos, man. Anyways, animation type will be generic, and you hit apply, and you see Unity re-imports them, and voila, we are good to go. So now select the idle animation, click on the circle, and now select the idle _0 animation. It works. Here is our idle animation. I can even now preview it if I select the warrior inside of the hierarchy panel, and if I go into the animation tab, so not the animator tab, but animation, which is located here. Window, animation, and animation. This is the animation tab. So I can click here the play button to preview it, and now we are previewing basically previewing the idle animation for our player. See, he's like moving. This is all the idle animation. Everything here that you see is basically the idle animation. And why am I actually running the game? Anyways, this is the idle animation as you just saw. So let's go back and create the rest of these animations. So we have here the idle. We are also going to have the walk animation. So right click here, create an empty state, and I'm going to call this one walk. And I'm going to click on the little circle, and I am going to select the walk animation. We are also going to have the attack animation. So right click here, empty state, and this one is going to be attack 1, and like this. We are also going to have another one for the attack, but let me just click here on the circle. And for the attack 1, I'm going to select attack _0. And let me just preview it quickly. So attack _0. Yeah, this is the one I want. And right click again and create an empty. And this one is going to be attack 2. Rename it to attack 2. And for the state, I'm going to select attack _1. But let me quickly preview it here. So attack _1, if I preview it, yeah, exactly, these two. So underscore or attack _0 and attack _1. And the last one is going to be create empty. And this one is going to be our defend animation. So defend like this. And for our defend animation, I'm going to click on the circle. And here we have counterattack, damage, defense _0. So select the defense _0. Again, if we preview it, it will be this one. You see, he's like moving his arm upwards to defend from the attack. So now we have these animations. We need to now create a script and handle these animations via script. So when we move, we want to simulate or play that move animation. When we attack, we want to play the attack animation. You get my point. But how can we do that? Well, in order to do that, we first need to create something that is called a parameter. So we need to create something that is called a parameter, and here, click on the plus sign. So click on the plus sign. And the first parameter that we're going to create is going to be the walk parameter. And if you notice, I clicked on the plus sign and selected the bool. So I'm going to do it again. So delete it, click on the plus sign, and this one is going to be a boolean. We are going to call him walk. So a boolean walk parameter. Now, the next parameter, we're going to click on the plus sign here, and we're going to create a trigger. And this one is going to be defend. And we're going to click on the plus button here and create another trigger. This one is going to be attack 1. Click on the plus button, trigger, and again, attack, but now 2. So attack 1 and 2. Walk, defend, attack 1, and attack 2. These are parameters because we need to have transitions. What are transitions? If I right click on the idle animation and I click here make transition, I can now point on the walk animation and click on it. Bam, you see this white line going from idle to walk? That means this is a transition from idle to walk animation. That means when we call this transition in our code, we will go from idle to walk animation. But this transition, in order for it to happen, it needs to have a condition, and this condition is right here. When you click on this line here, this arrow, when you click on it, it goes blue, and you have the properties here in the inspector panel. When you scroll a little bit down, you will see here conditions, and it's a list where we can click on this plus sign to add a condition. Well, the conditions are gonna be these right here, these parameters. So for example, if I click on the plus sign here and I'm gonna go from idle to walk, when the walk parameter is equal to true, and notice here in the drop down list I can select true or false because when we created this parameter it was a boolean. Boolean has a value true or false. So we will go from idle to walk animation when the walk parameter is or has a value true, and we will set that in our code. So we will set it in the code for it to have the true value, and when that happens we will transition from idle to walk animation. Similarly, Right click on the walk animation and make transition to the idle. And now we have two arrows, one pointing from idle to walk and another from walk to idle. So click on that arrow. And now I'm gonna click on the plus button here, and the walk here is gonna be false. Because when walk is true, we are gonna walk. When walk is false, we are gonna go back to the idle animation. Now we are also going to go from our idle to attack. So click on idle, make transition to attack. And we're also gonna make transition from attack back to idle. So click on this transition from idle to attack, and the condition here is going to be attack. Simply this right here, attack 1, because we're gonna go from idle to attack 1. It's a trigger. We will trigger that in our code. We will see if something is not clear right now. Wait until we get to the code part. Then I will have more material to explain it more clearly to you. We will see it visually and it will be even more clear. So we're also going to go from idle to attack 2 and make transition back. So click on the transition from idle to attack 2, and the condition is going to be attack 2. Don't worry about the transition from attack to idle. We will cover that. So don't worry, we will cover that. But basically, from attack 2 to idle, the transition or the parameter is going to be when walk is equal to false. Same here. From attack 1 to idle, the transition is going to be when walk is equal to false. Because why when walk is equal to false? Because we're also going to have from walk to attack 1 and from attack 1 back to walk. And this transition from walk to attack 1 is also going to have a attack 1 trigger parameter. But this parameter here, when we want to go back from attack to walk, that's when the walk will be equal to true. And similarly here, so from attack 2 back to walk, and from walk to attack 2, click on the transition from walk to attack 2, click on the plus button, and here we're going to select attack 2 trigger. And from attack 2 back to the walk will be true. But we will do something else here as well, so don't worry about that. We will come to it. We are also going to go in our code, and then everything will be clear. Now we're also going to go from idle to defend and back from defend to idle. So when we want to go from idle to defend, that's when defend will be equal to true. So when we click here, actually this defend parameter, excuse me, we're going to delete it. It's going to be a Boolean. So click here, bool, and defend is going to be a Boolean parameter, not a trigger. So attacks are going to be triggers, but here we're going to go from idle to defend when the defend parameter is equal to true. And we are going to go back from defend to idle when defend is equal to false, right here. Now we're also going to go from walk to the defend, and here we're going to set the condition defend is going to be equal to true, but we're not going to go back from defend to walk. We're only going to be able to go back from defend to idle animation. Now this is for setting them up. We will see them again in action. We will see them in action. Don't worry about that. Now, before we start coding, because we're going to go here in assets and scripts, and I'm going to right click here and I'm going to create a new C# script, and this one is going to be character animations. This is where we are going to create our animations. So this is where the animation magic is going to happen. But one thing to note is, remember those parameters that we used? Now let me demonstrate that. So here we're going to have a private animator, and I'm going to call him anim. And in the awake function, we are going to get a reference to it. So anim is equal to get component, animator component, voila. Now, this is where we are going to create our animations. And our first animation, I'm going to delete the update function, is going to be public void walk, which takes a bool. So bool walk parameter. And in order to execute it, we need to call here anim set bool. And that bool is going to be our walk parameter. And we're going to set the value to this walk that we pass right here. So we're going to set that walk, because we need to call it with the name. That's why we named it here. If we go here in the animator, and if we go into the parameters, you see the name is walk. It's same as with find game object with tag. So it's same with tagging. We need to have the name here. You see the walk, it's capital W. So also here, it needs to be capital W or otherwise it will not work. Now, this is what I was talking about a minute ago before we create these. You see, we have these parameters and you know I hate hard coding. So we're gonna go here in tags. Now, when I say I hate hard coding, there are some exceptions where you will use hard coding like this instead of creating it here. But we will see examples of that in some other tutorial. Don't worry about that. So don't worry that you will never use hard code. But if you're gonna use it often, it's better to put it here in a single script. So here I'm going to create a public class that I'm going to call animation tags. So, or actually not animations, animation tag without S here. And here we're going to have a public constant string. This one is going to be the walk parameter. And we're going to say here walk. So the value is going to be equal to walk, capital W, so capital W, or otherwise it will not work because the names need to match up. If here you have a lowercase w, so if here you have a lowercase w, then here as well you will use the lowercase. The point is the name you put here for the parameter, it needs to be exactly the same name you put right here. So we also have a public constant string defense or defend parameter, which is going to be equal to defend like this. This is the value, this is the name. And we're also going to have a public constant. So it's not connection. What am I doing here? Const string. And this is going to be attack underscore one underscore trigger, which is going to be equal to attack one like this. And public, so it's public constant string, not public, it's public. And instead of using here attack underscore two underscore trigger, because I want to differentiate them, I think it will be better if we put them like this. So it's attack underscore trigger underscore one and attack underscore trigger underscore two, because I can see this one and two clearly when they are at the end of the name, one instead of when they are in the middle of the variable name. So now we have everything basically, and we can go here in our character animations. Here for our walk, instead of using this, we're simply going to call our animation tags dot, and we're going to call the walk parameter. Bam, here it is. We are also going to have a public void defend animation, and here we're also going to have a bool defend, which is a parameter that we're going to pass. And here we're simply going to call animSetBool, and you call the parameter by the name. So let me explain that. So animation tags dot defend parameter, and here I'm going to call defend. And yes, I notice here that I did not type parameter, so I need to go back here in tags, and it's the defend parameter. Thank you very much. You see here, I'm calling setBool because when we created this parameter, we created it as a bool. When I click on the plus button and click bool, it's created as a bool. So you will call setBool. If it's an integer, you will call setInt. If it's a float, setFloat. If it's a trigger, setTrigger, which we will see right now. So here we're also going to have a public void attack underscore one. And here we're simply going to call animSetTrigger, not target, but setTrigger. And simply here we're going to call animation tags, so animation tags dot attack one trigger. Bam, it's like that. You see setTrigger. And for attack two, I'm going to duplicate this and paste it. And here instead of attack one, I'm going to say attack two. And here instead of underscore one, I'm going to say underscore two. And basically that is that. Bam, we are done with our animations. See, this is a class, and this is how I like to do things. I like to create a separate class for everything, and this is how Unity prefers it. Now, this is not my wisdom. I've heard that, I don't know what was the name, Will Goldstein or that Alan guy, the guys who do official Unity tutorials. I was watching one of their tutorials, and yes, I watch tutorials, don't judge me. I mean, I'm saying don't judge me, but you should also watch other tutorials as well. Anyways, I heard him saying that Unity prefers that you have a separate class for every separate task. So I like to separate my tasks. So here, this class will only handle animations. And now when we want to call these animations, for example, the move or the walk, we simply go here in the move script, And right here below our private character controller, we're going to say private character animations, and I'm going to call this one player animations or player animation, however you want to say. And here in the awake, I'm going to say player animations is equal to get component character animations. I'm calling it character animations, the class name, because we are also going to attach this on our enemies. Now, before I animate anything, I'm gonna go here in Unity and we need to attach that script on the warrior. If we don't attach it, it will not work. So select the warrior, click on add component and filter for character animations and click on that script and hit apply so that that change also applies to the prefab. So if we go back now in our Visual Studio, so if I go back here, at the bottom, I'm going to create void animate, and this is going to animate the walk. So animate walk, this is how I'm going to name it. So animate walk. And how are we going to animate the walk? Well, basically I said that the move direction, it is moving, so it has velocity. We can test it out, so we can call here if move, actually I'm saying move direction, but it's actually a character controller, so excuse me for that one. So the character controller, we're using it to move, so we can test it out. So we're going to say here if our character controller dot velocity dot square root magnitude is not equal to 0, then we are going to animate. We are going to call player animations dot walk is equal to true, else here we are going to call player animations dot walk is equal to false. Bam, bam, bam. What is this? Why are you bamming, teacher? I don't know why I'm bamming, but what this here is, we have our character controller and we are going to get the velocity. You see, the velocity is the velocity, speed over time. If we are moving, velocity will increase over time. Only if we are standing still. Now, this is from physics. I'm not no physics guru. I just know this from looking online. It's really very simple. So as I was saying, if we are moving, velocity will increase over time. If we are standing still, velocity will not increase. Think of it like you have a gas pedal in your car, and when you are pushing the gas pedal to the end, you know, the car does not go from 0 to 100 in a second. No, it goes slowly over time. Well, that slowly over time is the velocity. So if the velocity and the square root magnitude, you see this square root magnitude, and I need to do it like this because for some reason Visual Studio is giving me here some errors, I don't know, warnings for whatever reason, but let me go here, character controller, so char controller dot velocity, you see the current relative velocity of the character, meaning if he's moving or not. That the square root magnitude, it returns the length of this vector because the square root magnitude, basically, this velocity is a vector value. A vector has a value of x, y, and z. And why that? Because we have speed on the x, y, and z axis, and it will return that speed. This square root magnitude will make that value 1, which basically means if that value is not equal to 0, we are moving. So if that value, the velocity's square root magnitude, think of the square root magnitude simply converting this value into a 1, so number 1 value. If this velocity has any value, if it's 0, then it will return 0. The square root magnitude will return 0 if we are standing still. If we are moving, we will have any value here. We will convert that value to 1, which will not be equal to 0, meaning we are moving, meaning we will animate the walk. Meaning, if we are not moving, then we will not animate the walk. Instead, we will animate the idle animation. Before we proceed to test this out, we need to call the animate walk in the update function. So animate walk function, call it in the update function. And now we are ready to test things out. So if I go back here in Unity and if I hit the play button, when I move, we will see that we are not animating. Now, what is the reason? Pay attention here to the idle animation, this blue line. When this blue line finishes now, I'm gonna go to walk animation and walk animation freezes. What the hell is going on, teacher? You said that this right here will work. And why is it not working? First of all, let me fix these animations. So if I double click on the idle animation here, we need to make sure that the loop time is checked. So when you select the idle, if you double click on it, it will take you here to the settings of the animation. And if you scroll a little bit down, you have this loop time, which is right here that I have circled right now. This loop time, it needs to be checked because the idle animation needs to loop. And when you check it, hit apply at the bottom left, or excuse me, bottom right corner. Also do the same thing for the walk. Select it, double click it, scroll down, hit the loop time and hit apply, because again, the walk animation needs to loop. It needs to play over and over and over again for us to be able to simulate the walking and the idle animation. The defend animation here, so select it. For the defend animation, we will leave it for later. We will see what we're going to do with it because we're going to add some extra code for that as well. So we will leave it for now. These attack animations are not going to loop. But now, since these animations are looping, if I hit the play button, pay attention here in the animator. You see animations are moving. You see this blue line? It means that the animation is playing. But if I try to move, you see I'm moving, but you see only now the animation is playing. I don't know if you see this, and you pay attention here. You see what is going on? You see here? Now, what is the reason for this? Well, the reason for this are these transitions, so we need to fix them. If you select the transition from idle to walk animation, you will notice here that we have conditions. We set the conditions to be true. That is okay. But you also have these settings here, and you have the exit time. And pay attention here, this exit time, transitions has a fixed exit time. And if I hover over the exit time, it will say exit time in normalized time from current state. Basically, this means this exit time is how much time we have before we exit from the animation. And usually this means that we will let the animation to play till the end, which we saw. The blue line was filling up in the idle animation, and only when the blue line has finished filling up, that's when we transitioned to the walk animation. So in order to fix that, we're going to uncheck the has exit time, and the transition duration we're going to say at 0.1 because we want to transition as fast as we can from our idle to the walk animation. Now, in regards to the walk animation, we're going to do the same thing. So click here, the transition from walk to idle, uncheck has exit time, fixed duration is going to be equal to 0.1, simple like that. So what about transitions from idle to attack? Basically, we can test these two out first. So if I hit the play button now, pay attention. Now I'm going to now I'm going to start walking. You see, as soon as I started walking, he started to walk. You see, as soon as I started to walk, and here, what we need to do is the transition, or actually the condition is false, but I think in the code, so else player animations walk is equal to false. Something weird is going on here because the parameter here is okay, it's false, and we saw that in the animation nothing is wrong. So let me try this. I'm gonna print here and I'm gonna say the velocity is colon, and I'm going to say plus character controller, or char controller dot velocity dot square root magnitude, and I'm going to print that out to see the value quickly. So if I go here, let me just clear the console. And if I hit the play button, we'll see that initially it's set to 0, but now I'm going to start moving. So now it's 9 points, so on and so forth. I'm stopping, so I stopped moving. Whoa, never saw this before. You see, I don't move, but for some reason the character controller still has velocity. Now I'm really not sure what is going on, but let me try this. Let me try to stop our character controller instantly. So basically here, we're checking if input, so on and so forth. If we have input, we will move our character controller. Else, if we don't have input. So basically here, if we don't have any input to move the character, then we're simply going to say character controller.move, and here we're going to pass vector30. Again, vector30 is a shorthand for writing 0, 0, 0 for X, Y, and Z. And basically, it will stop the character controller from moving. So if I go back here in Unity and clear the console, and if I hit the play button, so if we go now, and if I stop, bam, it stops. You see, we just need to stop it, but I'm not sure why it's not stopping on its own. I'm using the same code from the project that I showed in the beginning. It's the exact same code. I'm following that. It worked like a charm. I did not use this character controller move 0, but basically if you have this issue, this is how you will fix it. And if I get to bottom of this issue, I will create a video talking about what the issue was. It's really interesting to see, but this is how we fixed it. So yeah, you need to improvise in programming as well. So this is how we stopped our character controller to make sure that the square root magnitude is equal to 0 indeed. So what I'm gonna do again is test it out so that we can see in action our transition. So if I walk now, you see automatically he goes from idle to walk. I'm gonna stop, automatically he goes back from walk to idle animation. The reason for that is because we edited these transitions, so we don't have the exit time. Transition duration is 0. Basically, exit time will allow us to finish the animation before we transition to another animation, and transition duration is how much seconds it will take for this transition to happen. So we set it 0.1. We want to happen as fast as possible, and we saw this in action, so now things are clear. You see here, we go from idle to walk when the walk parameter is equal to true. This is what we're doing here. Parameter walk is equal to true. And if I go into character animations, anim set bool, this is the walk parameter. We set it to this walk parameter that we have here. And we specify that walk to be either true or false. So if it's true, it will transition from idle to walk. And if it's false, it will transition back from walk to idle. And we talked about these parameter conditions or settings, exit time, fixed duration, so on and so forth. We explain what they are and what they did. And so now the animation is a little clearer, if not a lot more clear, what we are doing here. Now, this is in regards to the idle and the walk animation. We, of course, have these transitions that we need to fix, but I would rather first test it out and then we will proceed to fix them so that we can see it in action and make the animation concept even more clear. So for that, we need to go here in our project and scripts folder and right click here, and we are going to create a C# script that I'm going to call player attack input. And this is where we're going to get the input for the attack, and we are going to proceed to attack. So of course we need to attach this on our warrior character, and I'm going to hit apply. And now we're going to double click and open this script in Visual Studio. The first thing that I'm going to do is tag the class here at the bottom and give a little bit of space so that I can scroll up and down and we can see more clearly what am I doing here. So for now, the one thing that we need for our player attack input is going to be our character animations, and I set it to be private because we will use get component. And I'm going to name it player animation, and inside of the awake function, so change start to awake, we're going to say player animation is equal to get component, and we're going to get here the character animations component like this. So what is the next thing to do? Well, the next thing to do is to detect input. So we need to detect input in order to simulate the attacks, and we will simulate them with the animation. So when we press our key code, let's say J and K, so when we press J, we will defend ourselves, and when we press K, we will attack. So here, if our input get key, and we're going to see here key code dot J, so when we press J, we are going to defend ourselves. So defend when J pressed. And simply here, we are going to call our player animation. So we're going to say player animation defend, and here we're going to say true, because if you remember, if I go back here in Unity and inside of the animator component, or actually in the animator panel, you see here defend, we will go from idle to defend when defend is equal to true, and we will go from walk to defend when defend is equal to true. Now going back here, we set it to be equal to true, which means that when this is called, we will play the defend animation. Now this is when the key is pressed. What we want to do when the key is released? Well, we want to say here if input dot get key down, and this is going to be key code, so key code.j. Same key when we press it and when we release it, we are going to say here player animation defend now is equal to false. We will test this out in a moment. We will see some issues and we will fix them one by one, because I like to first show you the problem and then show you how to get to bottom of that problem. And here we're also going to say if input get key, and we're going to say here key code K. So when we press K, we are going to attack. But we have two attacks, if you remember. If I go back here in Unity, you see here we have attack 2 and we have attack 1. This is in our animator panel. So here they are, attack 2 and attack 1. So if I select the warrior here and if I zoom in on him, you will see here that if I select the attack 1 animation, you see now this is how he is attacking. If I select attack 2, this is how he is attacking. So how can we call these animations? Because I want to randomize that. And in order to randomize it, when we press our key code K, we're going to test here if our random.range from 0 to 2, if it's greater than 0. Now to declare this right here, right away, or actually to explain it. You see, this random range will return a random value between two numbers. When we use integers, if I hover over here, you see it is using integers. If we say here f and here f, it will think that we are using floats, which you will see here when I hover over random float. As you can see, random range for a float. But if I remove f and set it to be an integer, or actually just remove f, it will think we have integers. Why is this important? Because when it comes to integers, this number here is inclusive and this number here is exclusive. What does that mean? That means that inside of this random range, it will include this number, but it will not include this number, which means basically here it will return either 0 or 1. 2 will not be returned. It will return either 0 or 1. And if we have here, for example, 5, it will return 0, 1, 2, 3, and 4, but it will not return 5. So 5 is excluded. But if they are a float, so if I say here f, so 2f and 0f, that means we can either get 0, 1, or 2, or in between decimal point numbers. So when it comes to a float, both numbers are included. When it comes to an integer, then the second number is not included, which means this will either return 0 or 1, which means 50-50 chance to perform one attack or the second attack. So here I'm going to simply say player animation dot attack 1, and here I'm going to say else, and I'm simply going to say attack animation 2. So player animation and attack 2 animation, and voila, we are good to go. And since this is already being called in the update function, we can safely test it out. So we need to go here in Unity and pay attention now what is going to happen. So here I'm going to hit the play button. Pay attention to these animations. So let's say I press K. You see I pressed K. So what is happening? First of all, we need to wait for our random integer to pass. And let me just go here quickly. So here I'm calling attack 1 and here I'm calling attack 2. And in character animations, so here animations attack trigger 1 and here we have attack trigger 2. So let's go back here again and what is going on. Pay attention what is happening here. So I'm gonna press it and now we have attack 2. But again, we need to wait for the idle animation to finish because we did not check for these transitions. And now he's attacking and you see how much it takes to play the attack animation. So we need to fix this. And of course, in order to fix this, we are going to fix the transitions. So the transition from idle to attack 1, so here, it's not gonna have an exit time. And for the transition duration, I'm going to say here 0.3. This is from idle to attack 1. But when it comes to attack 1 back to idle, it's gonna have an exit time. And here the transition duration, I'm going to say 0.1. So the transition duration will be 0.1, but it will have an exit time with the value of 1. For our transition from idle to attack 2, we are not going to have exit time and 0.3 will be that transition duration. For this transition from attack 2 back to idle, we are going to check the exit time and the value will be 1. And here the transition duration will be equal to 1. Now when it comes from our attack or from walk to the attack animation, so this one right here, to attack 1, uncheck exit time, 0.3 for the transition duration. Going back here from attack 1 to walk, we are not gonna have, or actually exit time is going to be 1 and transition duration is going to be equal to 6. And similarly here, from walk to attack 2, we're not gonna have an exit time, but 0.3 for the transition duration. And for our other transition, same as with from attack 1 to walk, we will use the same thing for attack 2 to walk. So exit time will be 1 and transition duration will be 0.6. And for our defend, so we are also going to fix defend now because it will have the same issue. It will have the same issue as we just saw. So we are going to say here uncheck exit time and 0.3 for our transition duration. We're going to do the same exact thing here from walk to defend. So uncheck exit time, 0.3 for transition duration, and going back from defend to the idle animation, 1 for the exit time, 0.6 for the transition duration. So now let's test it out and see what we have here. So if I go and test it out again, so pay attention now. Did you see, I don't know if you see here that we are attacking with 2. We attack just 2. What is, you see here? I just pressed the number, I just pressed it once. You see, I pressed the animation only once, as you can see here. So again, but it's attacking multiple times. You see here, now I'm not even pressing a button. Now you're like, okay, teacher, do you know what you're doing? I do know what I'm doing, but I want to show you. So let's go back here. What is the problem? The problem is here, get key. So we should not use get key because get key returns true while the user holds down the key. Basically, when we press and when we hold the key. Now, of course, I did not hold the key. What I did is I simply pressed it, but since this is called in the update function, which is run every frame in a second, it can happen that I held unintentionally for 2-3 frames while I pressed the button. It was basically held in quotes, and those 2-3 frames caught that, and it is called that many times. So what we need, we only need to detect when we press down the button, and basically for that we are gonna say get key down. So you see here, get key down. This is what we need. And here also we're gonna say get key down, and here we're gonna say get key up. I wanted to write it before, but for some reason I wrote down. Get key down will detect when you press the button only once. So when you press it, and even if you hold it, it will detect that only once. Get key up, it will detect when you release the pressed key. We're gonna use this when we press this right here, we're gonna hold the shield, and when we release it, then we will release or lower down the shield. Now that we are using get key down, let's go here and let's test it out. So if I hit here the play button, so if I hit the play button, pay attention now. So if I press the key, you see now automatically only one time it is executed and only one time we go into the animation. Now, one thing that you're noticing is that the animation is very slow. So you see now he's like a slow motion when he attacks. You saw that. In order to fix that, you're simply going to select, and let me just go here, take the highlight tool. So you're gonna click on the animation right here, the motion state that is, and right here you have the speed of that animation. So it's right here where I'm pointing, and for attack 1 we're gonna say the speed is going to be 4, and for attack 2 we're gonna say the speed is 3. That means it will run 4 times as faster than its original speed, and this one, the other one, will run 3 times faster than its original speed, basically. So this is what we are saying. So now if I test it out, so if I go here and hit the play button, if I press, you see now how fast it is? So it's playing these animations fast. We are transitioning from one animation to another fast. You see, everything is basically working now. You see, and you can see here inside of the animator, the animations that are being played. So when I press here, automatically it goes to attack 2. When it finishes, it goes back to idle, so on and so forth. When I press the shield, you see, he is holding his hand, but I also release the button. So if I press it and hold it, you see now, he also gets back. We need to fix this. Now, in order for you to understand what I just said, we are going to import the shield and the sword. So if I go here in models, and here we have our weapon. So here is our weapon, this one right here. Did I import it? No, for some reason I did not. So basically this is our weapon, this right here. And the weapon, I'm going to call it sword. And we're going to click on the warrior drop-down list, then BIP object, then pelvis here, then spine 1, spine 2, then neck, then a right clavicle, upper arm. I know this is tedious, and here is our right hand. This is where we are going to position our shield. On the right hand, what you can do is you can type R hand, and here it is. So this one right here, the R hand. And you're gonna select the sword, and for the position here, X, I'm going to say negative 0.0389. For the position Y, I'm gonna say 0.0128, and for the Z, I'm gonna say 0.0034. Now the rotation X is going to be negative 127. The rotation Y is going to be equal to negative 100, and the rotation Z is going to be negative 104. So negative 104. Basically, that is that. This is how we are going to hold our sword, as you see right here. Now for the shield, so we're going to go back in models, and now we have shields, and here it is, and I'm going to rename it to shield. This one is going to be positioned under the left hand. So simply type here L hand, and here it is. When I say type here, I mean right here in the hierarchy search tab. So this one right here, you simply type L hand, and here it is. This sounds like some, I don't know, some swordsman, L hand. Anyways, take the shield and attach it here on the L hand. And let me just reposition it. So for the X position, it's gonna be 0.041. For the Y, it's gonna be negative 0.008. For the Z, it's going to be negative 0.005. And the rotation, 98 for the X. For the Y, 81. For the Z, it's going to be 180. And basically, that is that. So this is our shield, and this is our sword. Again, pause the video here if you want to copy these exact values where the shield is positioned. And as you can assume, when I was preparing this project, I have positioned this, experimented, moving it up, down, left, and right, until I got it to the place where, or to the position where I want it to be. And basically, now we have our shield and we have our sword. Now let me select the sword, and you can also pause the video for the sword. So if you want to position it, so this is where we can position our sword. And voila, this is it. So now if I go and test this out, you will see this in action way better. So now we have the sword. If you see, we are holding the sword, and if I press the key, you see now we are attacking with the sword. We are stabbing. Come on, stab. Okay, he stabbed and stabbed. Pay attention now if I hit this for the shield. You see he simply holds it up and lowers it down. If I hit the J key and hold it, you see again, he plays the animation, and now you see what is happening here. The animation is not working, basically. Now, the reason for that is, if I select the warrior and go to the defense 01 animation, this is that animation. This is how the full animation looks like. You see this right here. He basically puts the shield up, and then he lowers it down in the same animation. What we need to do is we need to freeze the animation where we are somewhere around here. So at the middle. Approximately, or frame, I don't know, frame 30, frame whatever. So basically when we are here somewhere, something like this, this is where we are going to freeze the animation so that it stops. And in order to do that, we need to go back in Visual Studio, and inside of the character animations right here at the bottom below our attack 2, we're going to create here void freeze animation, and not free but freeze. So it's freeze animation like this. And here we're simply going to say anim.speed is equal to 0. Now, setting the speed of the animator, and anim is our animator. If we set the speed to 0, that means we will basically turn it off, shut it down. It will not move. The speed is 0. And in order to turn it back or make it work like normal, so we're going to say public void unfreeze animation. And here, since we are unfreezing, we are going to say anim speed is equal to 1 again. So 0 and 1 is the speed for the animation. 0 stopping the animation completely. So stopping that animation completely. And again, for our freezing, we are going to set 0 and voila, we are good to go. Now this freeze animation, we are going to call inside of this animation right here. We're going to use animation events. Now you see this animation that we have imported. So I'm gonna say here clear. You see this animation defense, it's read only. If you pay attention here, it says read only. Read only means that we can only display this animation. We cannot edit this animation in any way. We cannot delete these steps for the animation. See, we cannot right click and remove properties. I cannot add any animation events right here. And in order to do that, what we need to do is locate this animation. So defense 0, here it is. It's inside of the models and animation, defense underscore 0, and this is the animation clip. So we want the animation clip, which is inside of this game object. You see here that I've circled, but this is the clip that we want. You see this? Defense underscore 0. What you're gonna do is you're going to take this clip and you're going to hold command on Mac. On Windows, you're going to hold control and you're going to press D. This will duplicate it. So now we have an independent defense animation. As you can see right here, we have an independent defense animation. What does it mean to be independent? Well, it means that our animation is not dependent on this one right here, on this defense that we have imported. And we're going to rename it to defense animation. And now I'm also going to check this loop time right here. So pay attention, when you click on this defense animation, you will have a loop time here. Check it because we want the loop time to be checked. And if I go here in Animator and select the defend animation, what I'm going to do is change the motion here for the clip. So this right here, exactly where this is pointing. So this one, I'm going to click on this little circle right here and filter for our defense animation. So click here, defense animation, here it is. Now because it's independent, it's not read only. If I select it here, it's not read only anymore. It's basically now we can edit it. So we can hit here the recording button, we can add more to this animation, so on and so forth. But this means that we can press this button. Notice this, and actually not this right here, so clear. You see this right here that I've just circled inside of the animation tab. That is called an animation event keyframe. So I can go, for example, here, and let's say, I don't know, at frame 20, exactly here. I want to add an animation event. So I'm gonna click on that button that I just showed you, this one right here that you see. So click on it. When you click on it, and let me just hide the highlight tool. So when you click on it, you will see now that in the inspector panel, first of all, you will see here at that frame, you see this blue line, that's the animation event. And when you click on it, you see the properties here in the inspector panel. Basically, this is a drop-down list that we can click here and we can select which one of these functions we want to be executed when we hit this frame. So when we hit this frame and go over this animation event inside of this animation. So I want to freeze the animation, so I'm gonna click here and select freeze animation. So now when we play this animation and we get to this point right here, it will hit or pass on this animation event, which has this function here. And this function is right here inside of our character animation script. So it will execute this function. And in order to unfreeze the animation, we need to go in our attack input and right here, key code up. We need to call here player animation.unfreeze animation in order for this to work. So here we are gonna unfreeze because inside of this animation, we are freezing it and our animator does not work. So in order for this to work, we need to unfreeze the animation and make the animator work like normal. So if I go here and hit the play button, pay attention now. If I press and hold the key code J, you see now he is holding, his shield. You see he is basically holding. If I release the button, he releases the shield. And this is how we can see this way better. So I'm gonna go here inside of the scene And here is our player. He's playing his idle animation. So pay attention on the scene view. I'm gonna press J. You see, he is holding the shield, and I'm pressing the J key and holding it. I'm currently holding it, and now I have released it, and he released that animation. So basically we simulated this with our animation and with our code. Again, what we did is in our character animation, we froze that. So we are calling freeze animation, which will be called at this exact frame. So defense animation at this frame right here, it will be called. So this is the frame right here, and it will be called at that frame. It will go inside of the script, which has this freeze animation function. It will execute here. And in our player attack, when we release the key, so get key up, defend when GA is pressed down. And here we're going to say release defense when J is released. So when J key is released. So when we release it, we unfreeze the animation and set the defend animation to false to go back to the idle animation. And now we can finally create our enemy because we have all the ingredients. Basically, our enemy is going to be the duplicate of our player. So what I'm gonna do here is duplicate the warrior, and I'm going to change him to, so his name actually, to enemy. So now we have the enemy name here. We are not gonna have the character controller, so we're gonna remove that. We are also going to remove player move script and player attack input. The only thing that we are going to leave here is the character animations. Now we are also going to have a box collider, so attach a box collider on the enemy. But what I'm gonna do is I am going to take the enemy and move him here. So right here, and I'm going to rotate him 180 degrees on the Y so that he is facing the player basically, as you can see right there. The enemy is over there, you can see him. So now, let me first edit this box collider because it's not in place. So for the Y position of the box collider, or the offset, it's going to be 0.92. Z, we're not going to touch. As you can see, I'm editing these right here. So the center for the Y is 0.92. The size X is going to be 0.28. The size Y is going to be 1.81. And the size Z is going to be 0.34. And voila, this is our collider right now. I'm also going to take the character animation and move it right here below our box collider. Yes, continue, break the prefab, I don't care, because we're gonna go here into navigation. Now, what is this navigation? What is this right here? Well, this navigation is, first of all, you can locate it here under Window and then AI and then Navigation. And probably this tab will be floating like this, so it will be floating. I'm gonna dock it right here where my inspector panel is. And what you're gonna do inside of this navigation is that we are going to bake our areas, bake the objects that we are basically going to use for navigation. So if I go on the fourth tab here, so pencil and clear, you see the fourth tab, which is object. When you select that, then you click on this right here, mesh renderers. So select on that, click there, and you see all of these game objects. So we're going to select all of these draw calls and the ground, and we're not gonna select anything else. So all of these and the ground. Basically, I'm going to click here, navigation static, and I'm going to say walkable, but for these draw calls, let me select them and uncheck the navigation static, but not walkable. So these are going to be not walkable, and the ground is going to be walkable. The word says it's self, so it's self-explanatory. Basically, walkable means we can walk on it, we will be able to navigate on it, and non-walkable is none or not walkable. So all of these draw calls, they're going to be not walkable. Click first navigation static and then not walkable. Then click on the ground, which is our cube, which is where our game objects are standing, which is our battlefield, and navigation static and then walkable. So when you do that, this is how you denote to Unity's AI system on the navigation that we can walk on these areas. Basically, these are not walkable, so it will avoid them. But these that are walkable, we can walk on them. And I'm going to go now in the Bake tab. Right next to the Object tab, we have the Bake tab. And simply click here, Bake at the bottom right corner. When you click on that, bam, Unity will do its thing. And you see here, these blue lines, or this is light blue or light green. I don't know what this color is, so don't judge me. Anyways, this what has this color, this light blue or green, this means that it is navigationable. We can walk on these, but those that don't have, for example, like this right here, this is not navigationable and we cannot walk on these areas. Why is this important? So now I'm gonna go back in the inspector panel and clear this T-mesh from the search. This is important because now we can select our enemy and I can attach another component, which is the NavMesh agent. So I'm gonna click add component and NavMesh agent, attach it, remove the character script or actually move it down. And this is our NavMesh agent. Now here for the angular speed, I'm going to set it 800. This is basically the rotation speed of the enemy, how fast he will rotate. So this is the only thing that I'm gonna change. So how fast he will rotate. Now that we have the enemy and we have baked the walkable areas, we attach the NavMesh agent. I'm going to go inside of the scripts folder and right click here and I'm going to create a new C# script, and this one is going to be our enemy controller. So I'm going to call it enemy, so come on, enemy controller, and select the enemy game object itself. So select it and drag and drop the enemy controller on the enemy. Now before we continue, let's go here in the prefabs and drag and drop the enemy prefab right here inside of the prefabs folder. And now we can go here in enemy and I can double click this enemy controller script and I can open it in Visual Studio. Let me just tag the class here and voila. Yeah, of course, why not? Why should not Visual Studio give me these red errors? Again, it's been open too much. This happened already, so I need to close it and I need to reload it or open it again for this to work. For some reason, it happens like this sometimes, so I don't know why. Don't ask me because I don't know. Anyways, in order for us to use the NavMesh agent, we need to say here using UnityEngine.ai, which is, well, where our NavMesh agent is located. AI is for artificial intelligence. I'm also going to create here a public enum that I'm going to call enemy state. And inside of this public enum, I'm going to create two states. We are either going to have the chase state or the attack state. So either chase or the attack. Now here, inside of our enemy controller, right here, right below that is, we are going to have a reference to a private character animation, which I'm going to call enemy anim. So enemy anim underscore anim. We're also going to have a private NavMesh agent, which is the nav agent that we have attached. He is going to help us navigate, and we will see that in a second. So NavMesh agent, which I'm going to call nav agent. We are also going to have a private transform, which is going to be our player target. We are also going to have a public float move underscore speed, which is going to be equal to 3.5. This is the movement speed of our NavMesh agent. We are also going to have a public float attack distance, so attack underscore distance, which is going to be equal to 1F. Now, this attack distance is the distance, how close can we get to our player before we start to attack. Basically, how close we get to the player before we start attacking. So attack distance. Public float chase after attack distance, which is going to be equal to 1F, and is going to be chase underscore player. So chase player after attack. Basically, if we attack and after that attack the player decides to run, this is going to be the distance we will allow him to run before we start attacking or chasing him. We will see that, don't worry. We are also going to have a private float wait before attack time, which is going to be equal to 3. This is how many seconds we're going to wait before we attack. We will see this in a second. And our private float attack timer. And this one is going to denote when we start or when should we attack. And of course, we also need this enemy state. So here I'm going to create a private enemy state, which I'm going to call enemy underscore state, like this. So now inside of the awake function, so awake, change start to awake, we need to get ourselves some references. First of all, we are going to get our enemy anim. So enemy anim is going to be equal to get component character animations. And we're also going to get the nav agent, which is going to be equal to get component nav mesh agent. We are also going to get our player. So we're going to say player target is going to be equal to game object. Find the game object with the tag, tags.player tag dot transform to get the player. And this is what we need for now. Inside of the start function, so right here in the start, so create the start function. Inside of the start function, we are going to set the enemy state to be equal to enemy state chase. And our attack timer is going to be equal to wait before attack time. Now, in order to understand this, we need to create two functions. So right here, we're going to create void chase player, like this, chase player. And right below, we're going to create void attack player, like this. And in the update function, if the enemy, so enemy state, enemy underscore state is equal to enemy state chase. So if it's equal to the chase, we're going to chase the player. If our enemy underscore state, so underscore, come on here, enemy underscore state is equal to enemy state attack, then we're going to attack our player like this. So we're going to attack him. Okay, now let's code it out. Don't worry, when I code this out, I will revise the code again and it will be very clear what is happening. So as you can see here in our chase, we are gonna say nav agent set destination. So set the destination. Come on, man, set destination. Player target dot position. What the hell is this? You see, set destination is the sets or updates the destination, triggering the calculation for a new path. Basically, the destination where the nav agent should go will be our player's position. This is the destination. Nav agent.speed is going to be equal to move speed. So this is the speed of the nav agent that we are going to use. And if our nav agent velocity.square root magnitude is equal to 0, then we are going to say enemy anim dot walk, and we're going to say here false. And this is basically the same thing as with our player else, except here we will not have those issues that we had actually with our player. So here we have now true. And right here below, we're going to test if our vector3 distance between the transform.position, which is the current position of the enemy, and our player target.position, if that is less than or equal to the attack distance, meaning we are in the distance where we can attack, enemy state is gonna be equal to enemy state attack. Basically, we can test this out because we set here the enemy state to chase, and here we're gonna set this to chase. So we can explain this right here. If I go in Unity, and if I take my warrior, so I'm going to take the warrior and I'm going to move him a little bit here, so a little bit away from the enemy. And before we test this out, if you remember, we created the enemy by duplicating the player. So what you need to do is select the enemy and make sure that the player tag is not selected. Because if we go back here in our script, we will get the player target by using the find game object with the tag. So tag player, it will search for that same tag. So you need to be careful with this. So select the enemy and go here, and I'm going to click on add tag and click on the plus button and create an enemy tag and select the enemy and tag the enemy with the enemy tag. And I'm going to hit apply button. So be careful with this because we are using the code here. We're using find game object with the tag player tag. And it will be confused if it has two tags and it only needs to find one. If it's find game objects with the tag, then it will get the array of game objects who have that tag player. But when we are searching only for one and we have two in the scene, then Unity will be confused and your code will be broken. So you need to pay attention for that. So if I hit the play button now and go back here in the scene view, you will see how the enemy is coming closer to the player. You see he is going towards the player when he gets where the player is. So basically he needs to stop here, but we did not tell him to stop. He goes here where the player is, and voila, that is that. Let me just see here if I take the player and if I position here. No, he arrived at his destination, and that is where the path ends. I thought that if I move the player, he will reevaluate his destination, but no, we need to do that through code. But let me explain what happened here. Basically, let's go from the top. This right here is our character animations in the nav mesh agent that we're using. So this is clear. This is the transform of the player. This is the move speed of our nav agent. This is the attack distance and chase player after attack distance. We will see this in more depth when we create our attack, so don't worry for these two. But what is going on here is that we are getting our component character animations, we are getting the component nav agent, and also we created here these states, by the way, chase and attack. And we set the state enemy by default to be chase. And here in the update, if the state is equal to chase, then we will chase the player. And when that happens, we are going to go inside of this function. So what does this function do? Basically, you see this function here will set the destination, meaning the target. Where should the nav agent go? Because the nav agent, you see this one right here that we have attached on our enemy. So let me select the enemy. You see the nav mesh agent. He is the one who knows how to navigate on these green lines or this green, light green area, because we bake that using Unity's navigation. All of that information is available to our nav agent. He knows how to navigate in this area. And for it to navigate, so for the nav agent to go towards a certain position, we need to call, here set the destination. So nav agent set its destination to the position where we want to go. We want to go towards the player. So where the player is, this is where we want to go. This is our destination. And here we set the speed to the movement speed. So move speed so that we can move by the speed that we added right here, which will set the speed of the nav agent while going towards this destination. Now you see here our nav agent, as if I run the game again, and if I click here on the scene, you see how the enemy is coming closer to the player. So our nav agent has velocity built inside of it. And we talked about velocity, it's speed over time. And I said the example, when you press your gas pedal on your car does not go from 0 to 100 in 1 second. It goes slowly. So while you're holding the gas pedal, it goes from 10, 20, 30, 40 up to 100 speed. That is velocity. It increases over time. Basically, if the nav agent is moving, the velocity has a value, and square root magnitude will simply set it to a number. Meaning, if that number is greater than 0, so if it's equal to 0, basically, that means we're not moving. So if the velocity's square root magnitude is equal to 0, we are not moving, which means we're not going to animate the walk animation. Else, if the square root magnitude is not equal to 0, meaning it's greater than 0, meaning we are moving, then we will set the walk to true, and we saw that we're animating our enemy. So I'm not going to go back, but we saw that in action. So the next thing here that we have is our vector3 distance, and this measures the distance between 2 points. Basically here I'm measuring the distance between the transform position, which is the current enemy's position, and between the player's position. So think of it like this. Actually, here is my highlight tool. Think of it like this. If the enemy is here and the player is here, I am measuring this distance between them. So this distance between them will be measured, and we will check if that distance is less than or equal to the attack distance. So if the distance, again, between the enemy and the player, if that distance is lower or equal to the attack distance, we are in the range where we can attack, then we are going to call here enemy state, change it to the attack state, which will make this true. So if the enemy state is equal to attack, we will call the attack function player. Now inside of this function here, what's gonna happen? We need to stop our nav mesh agent. You saw that he reached where the player is and he was moving basically. So let's do that again just to test it out to see what I'm talking about. So he will reach where the player's destination is. You see here, he's going towards the player, going. He gets where the player is and he stops, but basically he's not moving, but he is playing the move animation. We don't want that. What we need to do here is we need to call navAgent.velocity is equal to vector30. This will completely stop our nav mesh agent. It will make him stop in an instance. Basically, this is like you apply instant brake on your car and it brakes instantly. It does not move an inch after that. We're also going to say navAgent is stopped is equal to true. Basically, this will stop navAgent. navAgent is now not working. When we type here is stopped, and if I hover over, it will say the property holds the stop or resume condition for the navAgent. Even here, if we set the destination, but if we call here is stopped, so if I say navAgent is stopped and equal to true, it will stop. It will not try to go to this destination because it has instructions to stop. So now we stopped the navAgent by these two lines of code. The next thing to do is call our enemy walk or enemy anim walk is now equal to false. Our attack timer plus equals to time dot delta time, and if our attack timer is greater than wait, so wait before attack time, this is where we attack. And again, we have two attacks, so we're going to say if random dot range from 0 to 2 is greater than 0, 50-50 chance that we're going to attack with attack 1 or attack 2. So here we're simply going to say enemy anim dot attack 1 else, so not here enemy anim, but else attack 2. Voila. And we need to reset here the attack timer. So attack timer is equal to 0 so that we can basically attack again. Now we can test this out, but we also need to start chasing the player if we can attack, because the player can move away from us. This right here will stop the game object. It will stop it. Let me test it out and see that for yourself. So if I hit the play button now, let me just try to move a little bit closer to our enemy. So come on, just move a little bit closer. Go here into the scene. So pay attention now. The enemy will stop near the player. So it will stop and it will start attacking. You see, it starts to attack. But if we run away and voila, this is that. You see, but the enemy will continue attacking here. Does not know that we went. So we need to tell it that. So we basically need to tell our enemy that we run away. So going back here, right below this if statement, we need to test if our vector3 distance, again, the distance from the enemy transform position, and the distance from our player target position, if it's greater than the attack distance plus chase player after attack. So if this is true, then we're going to call navAgent is stopped is false, enabling navAgent to move. Enemy state is going to be equal to enemy state chase so that we can start chasing our player. So what is going on here? Basically, we saw that the enemy was coming towards the player. We explained that right here. We explained what is going on. Setting the navAgent destination towards the player will make the navAgent move towards the player. This is the speed. Here we are testing if we are moving, we will animate. If the distance is lower or equal to the attack distance, then we will attack. This happens when we attack. We stop the navAgent from moving. We tell him you are stopped. Don't use navAgent at that time. We set the walk to false, and now we trigger these attack timers. You saw that in the start function here, I set the attack timer to be equal to wait before attack time. And here I'm adding to the attack timer delta time. And when the attack timer has a value greater than wait before attack time, we will attack. Basically, this is that when we go here, and let me just bring the player closer to the enemy. So now pay attention, when the player gets as close to the enemy, he starts attacking right away. So that is that first attack. And now he waits, you see, he waits a little bit, then attacks again. Basically, this right here, because we set the attack timer to equal to wait before attack time, as soon as we add here time.delta time to the attack timer, it will have a value greater than wait before attack time. Because again, we set it here. We set that here to be equal to. So when we add a little bit value to it, it is greater, which means we can attack. I want to simulate that because as soon as we get close to the player, I want the enemy to attack the player. That's why it happened like that. And then we reset the attack timer to 0. If we don't call this, if I remove this from here, and if I go back, basically, let me just turn this off. I'm telling now the word basically too much. I don't know, for some reason. Let me just take the warrior and move him a little bit closer to the enemy so that we can test this out faster. So if I take the scene view, and as soon as the enemy comes here, he will attack once. And since we are not resetting the attack time, you see what is happening. Basically, he is attacking every second. Now, the reason for that is because the attack timer will always have a value greater than wait before attack time if we don't reset it back to 0. So now we are going to reset it back to 0, which will wait this many seconds that we specified right here. So now you understand these variables. We wait this many seconds, 3, that we specified here before we can attack. And we're adding time.delta time to the attack timer, so that eventually it will have a value greater than wait before attack time. And this is what we are doing here. And basically when we attack, again with the word basically. So after that, when this is true, we will test the random range between 0 and 2. If it's greater than 0, we will attack with the attack 1. If it's not greater than 0, then we will attack with the attack 2. Same as what we did with our player, randomizing the attack. And we explained this. So now we are coming close to this. You see vector 3 distance, transform position. So if the distance between the enemy and the player is greater than the attack distance, which is this one right here. So this is the attack distance plus this distance right here. So if it's greater, the attack distance plus this here, we're gonna give just a little space for the player so that he can run away before we start chasing him. And we can see that right here. So first of all, let me take the enemy and I'm going to set the attack distance at 1.3 because, and I'm gonna hit apply to apply that change to the prefab, because I don't want the enemy to come that close to the player. He can come at 1.3 distance, which is this distance right here. You will see now. You see this right here is exactly enough. And this is how it looks like in our game view. And basically you can play with this attack, again with the word basically, you can play with this attack distance value. So the higher the number, then the enemy will be far away from the player before he starts attacking. But pay attention now, when I start to run away, you see he will wait a moment or two before he starts chasing me. So he will wait the attack distance plus this chase after attack distance until he starts to chase. And here we need to say nav agent is stopped is false, because here we set it to be equal to true, which will stop the nav agent. So set it to true will stop it. If we don't call here this, so if we don't call now it's equal to false, to tell the nav agent that he is not stopped anymore, pay attention what will happen. So if I hit here the play button and the enemy will come close to me, so he will come close now, he will start attacking, but if I try to run away, you see he is not following me because he is stopped. You see, nothing is happening because we need to tell the nav agent is stopped now is false. Because again, here we set it to be true, and now we are telling him you are not stopped anymore, you can move, and he will start moving. And then we simply set the enemy state to chase, which again will make this right here true, which we'll call the chase player function. This will locate where the player is, setting the destination to the player's position, setting the speed to the nav agent, and moving the nav agent, animating him, all of this stuff that we already explained. And we are basically reusing these two functions one after another. And here, if we get again close to the player, then we will say state is attack, which will make this true, and it will execute the attack player function. And we explained everything, what is happening in the player attack function. So basically we are going from one function to another, chasing the player, then attacking. If he runs away, we chase him again, and again with the word basically, I don't know what's wrong with me. So when he runs away, we start chasing again. When we get close, we start attacking again. So what is the next step to do? Because we are attacking, but we are not dealing damage and we are not detecting that attack. Let's fix that. So go back in Unity and select the warrior here in the scene. I'm gonna zoom in on him and click on the sword. So this is our sword for the player, and I am going to right click on the sword game object itself and create an empty game object. This one is going to be the attack point. And I'm going to tag this attack point with, let's say, this orange color so that I can move it. And let's say somewhere around here, I think it's okay. So this is where it's going to be at 0.00188 for the y-axis. Just move him a little bit here, and basically that is that. So this is where the attack point is going to be for our warrior, and of course for our enemy is going to be at the same exact place. So let me just select the enemy here, click on its sword, and right click on the sword and create an empty. This is going to be the attack point for the enemy. And let me just copy this position. So 0.001959 for the y-axis, and bam, and I can also tag it here with the red color so that we can see where it is. So we see them both. So we see the orange one and we see the red one for the player and for the enemy respectively. What is the next thing to do? The next thing to do is right click here inside of our scripts folder and create a new C# script, and I'm going to call this one attack damage. And of course, as you can assume, we are going to attach this on the attack point. So select both of these attack points and go here and filter for the attack damage script, and basically voila. So now I'm gonna double click on the attack damage, and here it is. So what we're gonna do here is we're going to detect that collision. What we need for that collision? Well, we need here a public layer mask, which I'm going to call layer. We also need a public float radius, which is gonna be equal to by default 1. Notice it's public. We can edit this in the inspector panel. We also need a public float damage to deal damage, and that by default I'm gonna set to be equal to 1, of course, because it's public. We can change the value in the inspector panel. We don't need the start function for this one. We only need the update, and inside of the update we are going to say here collider array, which I'm going to call hits, is gonna be equal to physics overlap sphere at the transform position using the radius, using the layer that we have provided. What the hell is going on? You see this physics overlap sphere? It is going to overlap a sphere at this position with this radius and this layer. Basically, this is the following. So if I go here, come on, what are you doing to me? So here is the warrior. I'm gonna zoom on the warrior. We see where the point is. So we see where the point is. Here it is, this orange thing. If I take the animation of the warrior and let's say attack 0 and point, or actually pay attention here. I wanted to say pay attention, not point. Actually attack 2, because attack 2, you see it's like this. He moves the hand behind him and then he attacks. This overlap sphere will create a sphere at that position because we attached this on the attack point. That sphere will be created on this position where the attack point is. So it will be created like this. Think of it like this. This is my highlight tool here. So it will overlap a sphere at this position. It will create a sphere like this. It's a circle. Think of it as a circle. It will create that circle at this position. This is the radius of the circle. You know, circles have radius. So the larger the radius, the bigger the circle is. And this layer right here means that the circle will search for collisions with game objects that are put on this layer right here. Now, what the hell is this layer? This layer is this one right here. So if I go here and let me just clear the pencil, this is the layer. You see here at the hierarchy for every game object, you have this layer. All game objects are set on a default layer by default when you create them. And that layer can be used for collision detections. We can do things like this right here. We can check here in the code if we are colliding with a game object that is on that layer. We can even exclude collisions between layers with, well, the layer option. So what we're gonna do is we're gonna select the warrior. Let me just fold this. We're gonna select the warrior and we're gonna go under layer and we're gonna click on this add layer. Now this is a drop down list. When you click on the layer, you have the default ones that are created automatically by Unity, but we need our own. So I'm going to click here on add layer, and here I'm going to create two new ones. One is going to be the player, another one is going to be the enemy. So if I select the warrior and click here, and we're going to select the player, and you see this will pop up. Do you want to set the layer for all child game objects? No, only for the parent. We don't want these children game objects. We don't want them to have the player layer, because the warrior, the player, he is important. So we're gonna do the same thing for the enemy. Click here and select the enemy layer now. No, this object only. Hit apply here, hit apply here. Now, what is beautiful here is that we can, because here in our code, we are searching here for collision with the game object that is put on this layer right here. You see on this layer right here. So what we're gonna do is, we are simply gonna select the attack point for the player, and we're gonna search for the collision on the enemy layer, because the player is attacking the enemy, and I'm gonna hit apply to make that change apply to the prefab. And here for the enemy, I'm going to click on these fold, or however these are called, these arrows, and select the attack point for the enemy, and we're gonna search for collision on the player layer and click apply so that that change applies to the prefab. Because when we attack with the enemy, we are attacking the player, so we need to search for collisions with the player or for the player layer. And here we're searching for collisions with the enemy layer. Now, how can we know if we have collisions? Well, simply here, because this overlap sphere returns an array of hits or array of colliders. If we test here, if our hits dot length is greater than 0, that means we at least have one hit, meaning we at least touched one game object. So at least one game object is touched with this overlap sphere if the length of the array is greater than 0. And here simply we're going to say print, and I'm going to say touched the game object. And basically we can test this out right now. So if I go here in the console and clear everything, so clear from the console, if I go and try to attack, even if the enemy attacks me now, so pay attention in the console what will happen. You see, we are printing this too much. You see, it's printed like 300 times. You see it here in the console. We need to limit this. So we need to limit this. Well, how can we limit? When we touch our game object, we can simply say here, game object set active is equal to false. And this is how we can deactivate the attack point. But this will create another issue, because again, we are dealing damage here. Remember, here we are dealing damage. Here we are gonna get the health script and gonna apply that damage. And you saw it was called 300 times in a second. So the reason for that is because the game object is active in the scene. What will happen now is the following. When I go here and when we attack, pay attention. So only once, or actually it managed to attack me 2 times. Or actually, no, I attacked him once. So yeah, mine was also triggered and enemy was also triggered. But now we are not detecting collision between each other anymore. So we need a better solution. But by now, I hope that you get the point why we need to deactivate this game object. The reason for that is if we leave it open, if we leave it on, or actually leave it active, you saw that it is, every time it touches or detects that collision, it will execute the code. And here we're gonna do this. We're gonna say hits and the element that's at index 0.get component, and we're gonna get the health script component, and we're gonna say here apply damage, and we're gonna pass the damage for the float. Now we did not create this, but we will create it, and this is going to apply damage to our game objects. And if we allow it to apply that damage 300 times, as we saw a moment ago, then we cannot play our game. Our players will die instantly. So what we need to do is select these attack points and turn them off. So turn one attack point off, turn another attack point off. And for our warrior, so starting with the warrior, what I'm gonna do is go here in the player attack input, and right here below our character animation. So below the character animation, what I'm gonna do is I'm gonna create a public game object, which is going to be the attack point. And at the bottom here, I'm going to say void activate underscore attack point. And I'm going to say here attack point set active is true to activate that attack point. And below I'm going to say void deactivate underscore attack point. And simply here, I'm going to say attack point set active is equal to false, or set it to false. But one thing to note here is because we are deactivating here, there is a chance that we will deactivate this game object before it's even deactivated here. Because notice what we're going to do. Here we're going to test if our attack point, so attack point, is active in hierarchy. So if the attack point is active in the hierarchy, then we will deactivate it. The reason for that is because we're going to go now and we're going to take these two animations. So we're going to take the attack 01 and attack 02, or actually attack underscore 0. So click it here. Here it is. Attack underscore 0 and duplicate it. And attack underscore 1 and duplicate it. So I'm going to take the attack. This is going to be attack 2. And this one is going to be attack 1. So I'm going to name them attack 1 and attack 2. And go back in the animator and select this right here and change the motion or the animation clip from attack 0 to attack 1. And for the attack 2, do the same thing, except here we're going to select attack 2 because you can assume why. We already did this a moment ago. We're going to go in our animation tab right here, and for the attack 1, so I'm going to preview it. So this is how it looks like. And here I'm going to click on this animation event and I'm going to select to activate. So activate the attack point. And when it attacks, so somewhere around here, I'm going to click another animation event and I'm going to type here deactivate the attack point. And for our attack 2 animation, I'm going to do the same thing. So somewhere around here, this is where the attack will go, or this is where the animation will get, and I'm going to call here activate attack point. And when it gets here, I'm going to call another animation event and I'm going to say here deactivate attack point. So you get my point. So do you get why I'm doing this here? Because if we attack and we don't hit a player, if we get a hit here for the player or for the enemy, then we will deactivate the game object. But if we attack and we don't get collisions here, then when the animation finishes, let me go here, player attack input. When the animation finishes, then we will, as you can see, deactivate these attack points. And we're going to copy these two scripts and go inside of the enemy controller. And here, right below the enemy state, I'm going to say public game object attack point. So declaring the attack point and going here at the bottom, so right above the class declaration, and calling these two functions. And we don't have to do anything for the enemy because the enemy has the same animations. We're using the same animator controller for the enemy and for the player. So if we go here, we have the attack. As you can see, it has the exact same effect. What is left for us to do is select the warrior and drag and drop his attack point here inside of the player attack input. Sorry, I bugged there for a second. So player attack input, and for our enemy, select the enemy, and here for the enemy controller, drag and drop the attack point in the attack point and hit apply so that these changes apply to the prefab. And basically we are done. We can now test things out and I will explain them again. So let's go here in the console and see how things go. Notice now if I attack, so I'm attacking, the point is being activated, but we are not hitting the enemy. So now you see, and the enemy attacked me, but now you see why is this here necessary. The reason for that is because you saw I attacked. The enemy was not there. We activated the attack point, but we did not have any hit. We didn't have any hit here. So this will not be executed. It will not hit this line of code. So game object set active false will never be called. Meaning when we get to the animation frame where we call this, then if the attack point is active, this right here will test if it's active, meaning we did not call set active or it's basically active. If I select the ground and if I click here, this is now not active. You see when I click on this checkbox, which is right here, you see where the checkbox is? Right to the left side, right to the left side of the layer. That's the checkbox, and if we click on it, now it's unchecked, meaning the game object is not active. If it's checked, then the game object is active. We can even see it in the scene. And we are doing this exact thing in the code with this line of code. Set active is false, will not make it active and it's not visible in the scene, and true will make it visible and active in the scene. So this right here tests if the game object is active. If it is, then turn it off because we tried to attack, we activated it, but we did not make any hit, so yeah, it's not active. And now we can test it out. So if I go here, you see the enemy is attacking in and touch the game object. And here I touched him again. And now I touched him. And now he will attack me and he touched me. And now I touch him. I know this sounds weird. I touch him, he touched me. But hey, don't think of anything. Anyways, you get my point and you see how can we detect collision by using this right here. Now we can safely delete this because we see it is working. We printed everything out. So we see that we are detecting collision. So we are detecting we can touch the player and we can touch the enemy. So we can basically attack each other. The next thing to do is create this health script that we commented here out. So I'm going to copy this name health script and go here in Unity and go back in the project because we need to subtract the health value from our enemy when we attack with the player and vice versa. So in the scripts folder, right click here and create a new C# script, name it health script. And as you can assume, we are going to attach it on the enemy and on the player. So select both of them. So select them, click on add component and click here health, or actually filter for the health script. And voila, here is the health script. So we need to double click it and open it here in Visual Studio. Let me just tag the class here. Because inside of our health script, we are going to subtract the health value, which means that we're going to have here a public float health, which by default we can say it's equal to 100. So when we start the game, we are going to have 100 for the health. Now here I'm going to remove start and update, and we're going to have here a public void apply damage, which will take float damage as a parameter. And simply what we're going to do is we are going to say here health, so our health variable, minus equals the damage that we are passing here as a parameter because we are going to subtract damage from the health. Now this minus equals is a shorthand for writing health is equal to health minus damage. So instead of typing health is equal to health minus damage, we can simply say minus equals, and it is the same exact effect. And here, let me just tag it, so apply damage. And here we're going to test if our health is lower or equal to the value of 0, meaning health drop to 0. Here we're going to print, or we are going to say here, the character died. So the character died. And here in our attack damage, now we can uncomment this line of code and you can see here the beauty. So we have the damage here, which is the parameter. We set it to be public. Basically, this one is the local variable. And here we have the, as you can see, we're passing it as a parameter. We set it to be public, which means we can edit the value in the inspector panel. So when we call apply damage, we can say, for example, this value here to be 100, and it will subtract 100 from the current health value. Then it will test if the health value is less than or equal to 0. If that's the case, we will print that the character has died. Now, in order to see this in action, I'm going to go here in the console. Let me first clear the console, that is. And if I take the warrior, since we are, if you select here our warrior and the attack point, you will notice that the damage is 1. If I set the damage to be 20, for example, and go here, select the enemy, and you see here the health is currently 100. You can pay attention right here. Let me just clear my highlight tool here. I'm going to select the enemy, and now when I play the game, you will pay attention to the health value of the enemy. So let's go and attack the enemy. So here we are, and attacking, pay attention. Now it's 80, then 60, 40, 20, and one more, bam, you see the character died. So the character died. Now, this is not the effect that we want. We don't want to print simply in the console the character died. Instead, we want to do some things. And in order to do those things, we are going to create here a private float. XDET, this is going to be the rotation, which is going to be equal to -90, because what I'm going to do is, let me explain first. I'm gonna take the warrior here. And when one of the game objects dies, what I'm gonna do is simply rotate him backwards. So rotate him like this, negative 90 degrees, so he falls on the ground because we don't have a death animation. If I go here in models, so models and animation, we don't have here the death animation, so we cannot simulate that with an animation because this 3D model, for some reason, don't ask me why, I don't know. So I don't know why doesn't it have the death animation, but usually you will have a death animation and then you will play the death animation. But here we're going to simulate that. So we're going to say here private float x death, private float death underscore smooth. So smooth, which is going to be equal to 0.9f. Private float rotate underscore time, which is going to be equal to 0.23f. Private bool, which is going to be equal to, or name of it is going to be equal to player died. So what do we need to do? Well, now we're going to get back the update function. So we're going to say here update, and here what I'm going to say is if player died, so if that is true, so if our player has died, we are going to do what? We are going to call a function that we're going to call rotate after death. Now, of course, we did not create this function. So let me just go here, hit enter to give a little bit more space here. Come on, what are you doing? Here and here. So if player died, if this becomes true, and by the way, by default, a Boolean value is equal to false. So if we simply declare a Boolean value like this, so if we declare it, we don't type it's equal to false, or if it's equal to true, then by default, it will be equal to false. That means this right here will not be true. We need to set it to be true. And here we have this rotate after death. So simply here we're going to create this void rotate after death. And simply here we're going to call our transform Euler angles. You see the rotation as Euler angles in degrees. You see this Euler angles is vector 3, so we need to pass a vector 3. So this is going to be equal to new vector 3. And we have now values for x, y, and z. For our x, we're going to use matf.lerp from transform Euler angles x towards the x death in time.delta time, multiply that with the death smooth. For our y, we're going to say transform Euler angles y, and for z, transform Euler angles dot z. So what is going on right here? So what is this? Well, basically, we are going to lerp, and lerp means, you see this matf lerp, it linearly interpolates between a and b by t. This is a. In order to paint the picture, this lerp will go from this point to this point in this timely manner. So this is point A, so this is right here, point A, and this right here, this x that, excuse me, so let me just go here. So this is point A, this right here, this is point A, this x that is point B, so here we have point B, and t is time, so the time interval, which is this one right here, time.delta time multiplied with the dead smooth, that is t, or time. Now again, why time.delta time? Well, because to smooth things out, and you see here I'm using that smooth, so we need to smooth things out. Again, we will go from this value towards this value in this timely interval, and the current value of the Euler angle x, which is the rotation x, will be 0, and we're going to go towards the x death, which is negative 90, and basically that's what we are doing. And in order to activate this, what we need to do is here we're going to create an I enumerator, not enumerable, enumerator, and we're going to call this one player, or actually we're going to call it allow rotate, and here we're going to say player died is equal to true to allow the player to die. Basically, it will activate this right here. So it will go here in the if statement, this will be true, and it will activate the rotate after that function. Then we're going to say yield return new, wait for seconds, and that's going to be the rotate time, which is 0.9. If we go back here, this is the rotate time, actually 0.23. So this is the rotate time. And then simply here, we are going to call our player died is equal to false. Now we will see in a second why are we doing it like this. So if I go here, if health is less than or equal to 0, then we are going to die. So we are going to call here start coroutine, and we're going to call allow rotate coroutine, which will enable player dead is equal to true, which will make this true, which will go inside of this function, and it will rotate. So it will go from the current X rotation to this, the targeted, which is the X death rotation, which is -90 in this time interval, and we will leave the Y and the Z rotation intact. If I go back now, and what I'm gonna do is I'm gonna do that with the player. Or actually, let's test it out on the enemy, because we have the same script on the enemy first. So if I go here, I will need to attack the enemy 5 times. So 1, 2, 3, 4. And notice now, when I hit him, 5, bam, you see? But basically nothing happened. Why is that? Well, we need to also deal with some other things, such as we need to deactivate these scripts. If I select the warrior, for the warrior we will need to deactivate his animator, player move, so on and so forth. For the enemy we need to deactivate the nav agent, we need to deactivate the enemy controller. So we are going to start doing that with this variable. So we are going to create here a public bool variable that we are going to call isPlayer. So call it isPlayer like this. And when we die, so when we die here inside of this if statement, so if health is less than or equal to 0, the first thing that we need to do is we need to say here get component the animator, so animator component, and we need to say enabled is equal to false so that we can deactivate the animator. So deactivate the animator. Now next we are going to test here if isPlayer. So if we have a player, we are going to disable his script. So we are going to say here get component player move, and we're going to say enabled is equal to false. We're also going to say get component player attack input, and we're going to say enabled is equal to false. We're going to do 2 more things, but we will see that in a second. Else, if it's not the player, so if it's the enemy, then we are going to say here get component, and we're going to say enemy controller component enabled is equal to false. And we also need to say here get component nav mesh agent like this, and we need to say dot enabled is equal to false. But you see here we cannot do that because we need to go here and type using Unity engine.ai so that we are able to use nav mesh agent as a component and disable it. So you see here we have isPlayer and we have else, which is not for the player, and we are going to differentiate between the player and the enemy because they both carry this health script. So what we need to do is go here in Unity and select the warrior. So the warrior, we're going to select him, and he is going to have this isPlayer checkbox checked inside of the health script, and I'm going to hit apply to make changes to the prefab. So you see here the isPlayer is checked, but for the enemy isPlayer will not be checked, and I'm also going to hit apply for the enemy so that that change applies to the prefab. So for the enemy isPlayer is not going to be checked. So let's test this out right now and see if it actually works. So if I go here, I will need to attack the enemy 4 or actually 5 times. So one more time, notice one more time after I hit the enemy, bam. You see now the enemy falls, and pay attention. You see his nav agent is not active. His enemy controller is not active. So we had to disable those scripts. You see, we had to disable these scripts in order for this to work because we are simulating the rotation. We are simulating the death by simply rotating the character to fall down. Basically, this is what we are doing. So he is falling down, and this is how we are simulating that. But since we had the enemy controller script, which was attached on the enemy, we also had the nav agent, which was also attached on the enemy. They are interrupting this process right here. So we had to disable them. right here. So enabled is equal to false basically means this. If I select the enemy and I disable his enemy controller script and I run the game, you will see now that the enemy is standing over there. It's not working because if you pay attention here on the enemy, you see where his enemy controller script is. You see the checkbox right here. It is disabled, meaning this script will not function. If I enable it, bam, you see automatically he starts running towards me because his script is also running and it is working. Now let me take here the enemy, and what I'm gonna do is for the enemy attack point, I'm going to set the damage to be equal to 5 to make this somewhat a fair battle. And I'm also going to take the warrior and set his health to be equal to 5. So set the health of the player to be equal to 5 because we want to test this out. I want to show you two issues that we have. Pay attention now when the enemy kills the player. Bam, you see the camera went over here, and notice the enemy is still attacking. Pay attention, the enemy is attacking and the player or the camera is at the ground. So we need to add 2 more lines of code here if is player. So if is player, we're gonna disable the player move and the attack input. And notice here, we are disabling the animator for both the enemy and the player. So we're disabling for both, again, the enemy and the player, because we don't want their animator to play anymore. But here, if is player, and we checked the checkbox for the player, so we saw how that goes. So we checked the checkbox. If is player, then we also need to do 2 more things. We need to say here our camera, so camera main dot transform set parent is now equal to null, because pay attention here, the camera, and let me just fold all of these, so fold this and this. You see the camera is a child of our player. So whatever the player does, so if the player is being rotated, let me select the warrior. If I rotate the player, you see the camera is following because the camera is a child of the player. Whatever the player does, if he moves left, the camera moves along with it. If he moves right, the camera moves along with him. So if he rotates, the camera will rotate because it's a child of the warrior game object. So what we need to do is we need to set the parent of the camera null, meaning the player is not the parent game object for the camera anymore. And you also saw that the enemy was attacking, so we need to disable the enemy script. We need to make the enemy basically not attack the player, and we are going to do that by calling here game object, find the game object with the tag, tags.enemy tag, so enemy underscore tag, and we need to create this enemy tag in the tag, so going here, and here we're going to say public constant string enemy tag is equal to here enemy. So we are going to get the enemy, and we're going to say here dot get component, and we're going to get our enemy controller component, and we're going to say that enabled is now equal to false because we want to deactivate our enemy game object. We can now test this out, but we need to make sure 2 things. First of all, you need to make sure that the enemy is tagged with the enemy tag and that the camera main is also tagged. So if I go back here, select the enemy, you see that the enemy is tagged with the enemy tag. Select the camera in player, so this one right here, see the camera in player, and it's untagged. So we need to select this main camera tag. It is built by default, so by default it is in Unity. So select the camera in player and put the main camera tag on it, because as I said, this camera main, it's built in Unity, and if I hover over, it will say the first enabled camera tagged main camera. So in order to do this or use this in our code, we need to tag the camera with the main camera. And if I test this out now, because I have set the health of my player to 5, as soon as the enemy attacks me, notice now, I'm dead, the enemy is standing still, he is not attacking me because we disabled his enemy controller script. As you can see, he is playing his idle animation, and I'm standing here dead, or laying down dead. And the camera, pay attention, the camera is now free. If I select, here it is, you see camera in player is now free. It's not under the player game object, it's completely free. It does not have a parent game object anymore. Basically, this is what we did. So again, here briefly, we are testing here if health is less than or equal to 0. This is clear. When that happens, we will disable the animator. We don't want to animate. We will allow to rotate, and we explained here what we are doing. Because we only want to rotate 90 degrees angles, we are going to allow the rotation, wait for the rotate time, and disable or set the player that died is equal to false so that we don't activate or don't do this anymore. Because if I remove this right here, let me just go and test it out. So if I go here and wait for our enemy to come closer, come on, Unity, run the program, run. Notice now when the enemy hits me, bam, you see? You see? This is the reason why. This is the reason why I am allowing and then not allowing. So if I say here player died true, then we will allow to rotate, then we will not allow to rotate. You saw the reason why. Because this right here will execute over and over and over, and we don't want to allow it to glitch, as you saw a moment ago. So what is the next thing to do? The next thing to do is to display the health values to our user. So if I go here in Unity, I'm going to create a UI canvas. Now, I cannot go too much into UI. I will cover that in some other video, so it will be too much. This video is already almost, I don't know, 3 hours. Anyways, I'm gonna right click here and go under UI and create a image. So let's go here and create an image. And this is our UI canvas, and I'm going to name it to UI canvas. And we're going to leave it at screen space overlay, which means basically it will overlay the screen, but I'm going to set this canvas scaler script to constant pixel size to screen with screen size, or scale, excuse me, not screen with screen size, scale with screen size. Reference resolution is going to be 1280 by 720. And I'm going to say here 0.5 to match width and height equally. Basically what I did here is that this canvas will take this reference resolution at like its main resolution, and it will try to make these game objects apply or resize according to this resolution. As I said, I will cover canvas and everything specific to the canvas in a separate video. So now I'm gonna right click on the canvas and create an empty game object. And this empty game object is going to be our player health. It's going to be empty, as I already said. And we're going to set the width and the height 1280 by 720. And the first thing that we're going to do with this player health, I'm going to right click here, go under UI and create a text component. And I'm going to rename it here to player text. And there inside of the text, we're going to type player. This is what's going to be displayed. I'm also going to align the text at the center, or actually we're going to align it left but center. So left here, center, but from the left side. The font size is going to be 59, and I know that you currently don't see the text, but you will see it in a moment. The color is going to be white, so click here on the color. If you ever worked in Photoshop or any other editing software in regards to images, you will know these options, or any text software. So you know the alignment, you know what is a font size, you know what is a font style, bold, italic, normal, so on and so forth. Now for the width of our text, I'm going to say 386, and for the height, I'm going to say 81. I'm also going to set here the anchor at the top left corner. Basically, this will make the center of the player the top left corner. So this is the anchor. It will make the center of our text top left corner. The position X is going to be 214, and the position Y is going to be -40. So this is for our player. The next thing to do is create our BG, which is our image. I'm simply going to drag and drop it here under the player health. So drag and drop the image, and I'm going to rename it to BG. Set the anchor of it to top left corner, and the width is going to be 228. The height is going to be 29, and I'm going to set here the position X at 130, and the position Y is going to be -101. Now I also need to duplicate this health, so I'm going to duplicate it, this BG, and I'm going to rename it to player health display. And for this one, we need to go here in our project and UI, and we have this health UI, which is simply this image, this white thing right here. But what we need to do is we need to select it, And in the inspector panel, because if I try to drag and drop it right now here, it's not gonna work. And let me just clear here. I can drag and drop it here for the image to be represented by that image, but it's not working now because the default value or the default texture type of this image is set to default. You need to click here on this right here where it says texture type. So you need to click on that and you need to select this Sprite 2D and UI and hit apply at the bottom right corner. So now we are able to use this health UI as an UI, or actually drag and drop it here and simply create a health UI from it. Now again, you don't see the difference, but now I can click on the color and I can change the color to red, which you can see. But what's more important, I can click on this image type inside of the image script. I can click on the image type and I can set it to be filled. And I can change this from radial to horizontal, and pay attention now when I move the slider left and right. So you see I'm moving the slider left and right, and we are filling up the image with this red value. We are filling it up, you see, and lowering. This is going to be our health. This is going to display the health. So what I'm gonna do is duplicate this player health and rename it to enemy health. So here, enemy health. And I'm going to take the text and it is going to be enemy text. And position is 214, but I'm going to set the anchor at the top right corner and the position is going to be negative 214 and the alignment is going to be on the right side. And here we are going to say enemy like this. For the BG, we're going to do the same thing. So X is 130, set the anchor at the top right corner, and this one is going to be negative 130. And for our enemy display health, so change it from player to enemy health display, I'm going to set the anchor at the top right corner and set the X position to negative 130. But you see now we need to change the origin of the fill because it is filling from the right side. We need to change it to the left, and this is all, or this happens in all of these options. So right here, so you see the fill right here, I change it from left to right. So select on this drop down list, change it from left to right. So now when we fill, you see it's going from this side or from the left to the right. Now, what we need to do to make this happen is simply go here in our Visual Studio and in the health script right here, we also need to type below using Unity Engine AI, we need to type using UI. So Unity Engine.UI, and right below our public bool is player, we're going to create a private image, which I'm going to name health UI. And we made it private because we don't want it to be accessed in any other class. So don't want it to be accessed in any other class, but we also want to drag and drop. So we want to drag and drop these health display values in appropriate slots. So you see here, we don't see them, but since we made it private, I'm simply going to say here serialize field, and it will make them visible now in the inspector panel. So you see now they will be visible in the inspector panel. So for the warrior, drag and drop the player health display. And for our enemy health, or actually for the enemy, drag and drop the enemy health display. So for the warrior, we have the warrior or player health display. For enemy, we have the enemy health display. And inside of here, inside of our apply damage, right here, after we subtract from the health the damage value, we are simply going to say here if our health UI, so health UI is not equal to null, so we have a reference, we're going to say health UI.fill is equal to the health value, but we need to divide that by 100, because if you go back here in Unity, you will see that when you select, let's say for the player health display, if you select it, you will see that the fill amount goes from the value of 0 up to 1. So it goes from 0 to 1. It cannot go from 0 to 100. So from 0 to 1, that's why we are dividing this by 100. Because if the health current value is 100, and we subtract from it 20, that will be 80. 80 divided by 100, it's 8. So that's why we are actually not 8, but 0.8, excuse me. So 80, if we divide 80 by 100, so 100, that's equal to 0.8. And it will fill that image amount. So if we go back here in Unity, what I'm going to do is set the warrior health back to 100, and for the enemy health, so select the enemy, the health is also equal to 100. So what we need to do inside, or actually now simply test it out. So if I hit the play button, let's go here and pay attention now when the enemy attacks the player. You see now, pay attention to the player's health value. It's decreasing. And also when I attack the enemy, you see I'm decreasing his health value, decreasing even more and even more and even more. And when I hit him one more time, he dies. And as you can see, he is lying dead. And basically this is how we are going to display the health value. Now that we are displaying the health value, let's shield ourselves from the enemy. And in order to do that, I'm going to go here in scripts and right click and go here C# script and create a player shield script. As you can assume, this is only going to be attached on the player. So select the player and drag and drop the player shield script on him. Hit apply so that change applies to the prefab. Go here and double click player shield, and this one is going to be a very simple script. Here we are going to have a private, and that is going to be our health script. So health script, which I'm going to call health script. And in the awake function, we're going to get a reference to it. So awake here, and we're simply going to say health script is equal to get component health, not head off, health script component. And here we're going to have a public void activate shield, which is going to take a bool shield active. And what we need to do here, first of all, we need to go in the health script and we need to create here a public bool, and this one is going to be shield activated. And it is public because I want to access it here, because I want to say here health script dot shield activated is equal to this value here, shield active. So it will be either true or false. So that's why I want it to be public. I don't want it to be private, because if I set it to be private, it will not be able to access it here. You see, it's inaccessible due to its protection level. So we cannot access it because of its protection level. So we need to make it public, but I don't want it to be visible in the inspector panel. If I go here and select the warrior, pay attention to the player health script. I don't want this shield activated to be visible here. So what can I do? Same as here, serialize field for the private variable. We can say open square bracket hide in inspector for a public variable, and it will be hidden in the inspector panel. Now, what we're gonna do with this shield activated is here on top of our apply damage. You see, I'm going to say if shield activated, I'm simply going to say return. Now you're like, but we cannot use return in a void function. Yes, we cannot use it to return a value, but if we say here return, this will break out of the function. What do I mean by break out of the function? Imagine like this, if this is true, when we enter this apply damage function, so this is the first thing that we're going to check. If this is false, then we will proceed down to execute the rest of the code. So from here up to the bottom where we have the code inside of this function. But if this is true, if shield activated is true, and we hit this return statement, we will exit out of this function. So we will go outside and we will not proceed below to execute all of the code that we have. So we will not proceed to execute the code. Basically, we will exit out of the function. In order to see this in action, I'm going to go here in our player attack input right here. And right below our public game object attack point, we're going to create a private player shield, which I'm going to call shield. In the awake function, we're going to say shield is equal to get component, and we are going to say here player shield component. And simply here when we defend, you see when we defend, we are going to say shield.activate shield is true. And when we release the J key, we are going to say here shield activate shield is now equal to false, which will go inside of this script right here. It will call this function, and passing here true or false, it will assign that value to the health script shield activated, which is this value right here again. So it's this value right here, shield activated. And if that is true, it will return and break outside of the function. And we can test it out. If I go back in Unity, let me just clear the console. This works only if you press the J key and hold it. It does not work if you press and release it. If you just press it and release it, it will not work. So you need to press and hold it. Pay attention now. If I go here, so if the enemy attacks me now, pay attention to my health. It's going to subtract. Again, it's going to subtract. And now I'm going to hold the shield. Pay attention to the health value. Pay above. Pay above. Pay attention above. You see the player health value is not decreasing while I'm holding. If I release, now he is going to subtract value. If I press and don't hold, you see, if I press and don't hold, it's not going to work. So you need to press and hold. So press and hold for this to work, because this is what we're doing in our attack input. If we press the key down, then we will defend. If we release the key up, then we will, well, release the key and then we will not defend. So you need to press and hold for this to work, and release then for it to, well, not defend itself anymore. So this is for our defense. The last thing that is left for us to do is create our sound effects. So let's go back in Unity, and I'm going to right click on our warrior and create an empty game object. This is going to be our player sound, like this. And here we're going to click on add component and filter for the audio source component, and voila. But I'm also going to uncheck this play on awake checkbox. So don't check this, because it will play a sound, any clip that we attach here on awake. We don't want that. I'm also going to do the same thing for the enemy. Right click on the enemy and create an empty game object, and we're going to call this one enemy sound. And here attach the audio source, uncheck play on awake. And go here in our project and in scripts and right click and C# script. I'm going to call this one character sound FX. Select the enemy sound and the player sound, so select them both. Click on add component and attach the character sound effects. Voila. And we do need to hit apply for the enemy and for the warrior, so for both of them, so that change applies to the prefab. And now open, so select the player sound or character effects sound script, open it, and what we are gonna do here is we're going to get a reference to the private audio source. So here on top, private audio source, which I'm going to call sound FX, and we're going to do that in the awake function. So awake sound FX is equal to get component audio source component. We are also going to have here private audio clips. So audio clip attack. So attack underscore sound underscore 1, attack underscore sound underscore 2, and die sound. Simple like that. Now they are private, but we don't want to allow them to be used in other scripts, but we are going to make them serialized field because we're going to drag and drop them. And here we are simply going to create a public void attack function underscore 1. So attack 1, and we're going to play the attack 1 sound. So we're simply going to say sound fx dot audio clip, or simply clip, is equal to attack sound 1, and simply call sound effects dot play to play that sound effect. It's simple like this. Programming is beautiful. If you want to change a clip that's attached to the audio source, dot clip, so you say sound effects or the audio source dot clip is equal to the clip you want to attach, sound effects or the audio source dot play to play that sound. And I'm going to duplicate this function, and this here is going to be attack 2, and we're going to attach the attack 2 sound. And here we're going to have our die sound, so public void die, and we're going to attach here the die sound and play the die sound. It's simple as that. Now, this character sound we are going to have in our health script. We are going to have it in our player attack. So let me just go here, player attack, health, and enemy controller. Now, what we need to do is we need to declare here private in the health script, that is. So private, and we're going to say here character sound effects, and we can call it sound effects. So I can call it sound, sound effects like this. And inside of the awake function, so void awake, we are going to say here sound fx is equal to get component in children, like this, and we're going to say character sound effects. Now, why get component in children? Because if we go back here, you will notice that this player sound is a child of the game object. We cannot say get component. We use get component on the game object itself. So if we, for example, we have the warrior game object. If we want to get the character controller, then we will say get component because it's attached on him. But if we want to use this script, character sound, which is attached on the warrior, then we need, or actually, excuse me, attached on the player sound, which is a child of the warrior, then we need to use get component in children. And pay attention, this only works if you have only one script attached. So if we have a duplicate, if we have two player sounds, it will work, but it will get you one of these. It will not get you both. It will get you one of these. So when you have one, like here, player sound, it only has this character sound effects, then you can use get component in children and it will get you that one component. And since we are here, I'm gonna go quickly in sounds. And here we have arena, so these are arena sounds, unit, and these are attack sounds. So you can preview them, you can click on it and preview it here. This is attack 1 or attack 0. Here we have this one and this one. I'm going to attach these two. So select the enemy sound and player sound. I'm gonna attach man attack 1 and man attack 2 for the sound attack 1 and 2. And for the die sound, let's see this one. Yeah, this one can do. Yeah, the second one. I mean, you can play with these and you can take any one that you want. So for our player sound, I'm going to attach that 2. And for our enemy sound, I'm going to attach, I don't know, that 9. I'm not going to even check it out. So I'm going to hit here, apply, and apply for this one as well. I'm not even going to check it, as I said, because, well, we don't care. We have the attack sound, we have the dead sound, so it's not important how they sound. So let's go back here. We have the sound effects, and we're going to get it here. And when we die, so this is where we die in our health. And if health is less than or equal to 0, we are going to call sound effects die. And this will work both for the player and both for the enemy. So when they die, they will display the die sound. And before we test it out, I'm going to go also here in our player attack. So right here, I'm going to create private character sound effects. And this is going to be sound effects. And simply here, sound effects is going to be equal to get component in children. Character sound effects, and I'm going to copy this line of code because we're going to use it in our enemy controller. And when we attack, so this is where we are attacking. So here I'm going to call sound effects dot attack 1 sound, and here I'm going to say sound effects dot attack 2 sound. Simple as that. It's very simple. So when we attack with the one attack, sound attack 1. When we attack with the second attack, attack 2. And we're going to do the same thing here for our enemy. So if I go here in our enemy, right here at the top, private, character sound effects, sound FX. Right here in the awake below our player target, sound effects is equal to get component in children and get that component. And when we attack here, so let's go in the attack, here it is, attack anim1. So we are simply going to say sound effects, attack 1. Copy this and paste it below and attack 2. This does not require any explanation because it's self-explanatory. I've explained it right here. So we are going to call the clip and attack, and here simply set the clip to the clip that we want and play it. Set the clip to the clip that we want and play it. and voila, it's gonna do that for us. And we are calling this when we attack. So when we attack, we will play attack 1 sound and attack 2 sound when we attack with the second attack. This is what we are doing for the enemy and for the player as well. Now, in order to spice this up, we are basically done with our game. So we are done. And in order to spice this up, what I'm gonna do is right click here and create an empty game object. This is going to be our BG sound. And I'm going to reset the position and attach 2 audio source components. So audio source here and another audio source, so 2 of them. Because I'm gonna go here inside of this sounds and arena, and we have these arena sounds, so you see? And this one also. So pay attention. What I'm gonna do is select the BG sound, and for the first one attach the arena 1 sound, and for the second one arena _2 sound. And pay attention here, play on awake. If you don't check it, so if it's not checked, if I run the game, we will not hear these sounds. So if I run the game, the sounds, we don't hear them. So make sure that you check these check boxes. So I'm gonna check play on awake, let me just find it, play on awake, and loop. Loop means when the sound effect finishes to play, same like on your, it's same like in your MP3 app. So when you click loop, it will repeat the song. So check here, play on awake and loop. And notice here, it's warning us that we have 2 audio listeners in our game. Now, the reason for this is because we have one main camera that has an audio listener, and we also have another camera that's attached on the player that has a listener. So you see here, camera here and camera here. So I'm gonna take the main camera, this one that's not active, and remove the audio listener from it, because this is the audio listener that will be getting that sound and make us hear the sound effect. Now, also one thing that you have in this audio source is the volume. So pay attention here, I have the volume. 1, it's 100. So I'm gonna lower it. For Arena 1, I'm going to say 0.4, for example. And for Arena 2, I'm going to say, I don't know, 0.25 maybe. Because I don't want that sound to be heard like we heard it a moment ago. It's too loud for our game. And practically, congratulations, this is our game. We are finished. We can test it out to hear the sound effects. So I'm gonna shut up. So you see here, and let me just check here. Again, we have 2 listeners. So let me just find where they are. So we have UI, where are these 2 listeners? So we have the main camera, we have here, camera in player, audio listener, and event system. I don't know where the second listener is. It will not hurt our game if you find and just remove it. Let me just remove it from here. So select the camera in player and remove it. So let's see if we can hear it now. I literally don't know where the second audio listener is, but if you find it, just remove it. I don't care. It's not important. It will not hurt our game and we can play our game. So hear the sound effects and also pay attention to the player sound depth and also for the enemy and their attack sound. So pay attention now. You hear? I don't think we can hear it because of these sounds. So BG sound, I don't know, this one is gonna be at 0.2 and this one is gonna be at 0.1. So like this. So the volume for this one, actually I set the pitch here. So pitch is at 1. Volume needs to be at 0.4, excuse me, for this one. And for this one, 0.25. So it can work now. I forgot I set the pitch, not the volume. So yeah, set the volume to 0.4 and 0.25 for the second one so that we can hear it. So pay attention now. Yeah, now we can hear it a little bit. Something like this. Yeah. 0.1. or 0.2 for the volume here, and for this one is gonna be 0.1. Finally, I decided which volume I want. So hit the play button and let's test it out finally. So you hear it, listen to the attack sounds. Again, and again. So now when I hit him, he will die. And you heard the die sound effect. And we can also test for the player to see if the player can die. So I'm gonna set the health value to 5 and we will die instantly just so that we can test that the die works for the player as well. So pay attention now. Voila. So the die also works for the player. He is dead. The enemy will be standing still because well, we talked about it. We deactivated scripts, so on and so forth. Now, congratulations. This is a big project. Even though it's not that big when you look at it visually, we don't have 20 players fighting with each other, but we learned combat. We learned melee battle system. We learned how to deal damage, how to subtract health, and all of the good stuff that you don't see in any other tutorial online. Basically, you cannot find this anywhere else on YouTube. So yeah, thank you, Awesome Dudes, and you're welcome. Anyways, if you want more awesome tutorials, go on awesometudes.com, subscribe there. Actually, awesometudes.com. Go on YouTube/awesometudes and subscribe on my channel, and you will have more cool tutorials like these. Until then, Fahir here, and by the way, you can download this complete project, and all the assets, link is in the description below. Until next time, Fahir here from awesometudes.com. I will see you guys in another video.